The planet rises in the mind like a lantern of storms. It turns slowly in a field of ink, a colossal sphere wrapped in ribbons that never end, each one a river of atmosphere braided with the next. Cream bands, copper belts, bruised ochres, and pale blues spread across a globe too large for easy thought, and yet intimate in the way a heartbeat is intimate. No known mountain casts a shadow there. No coastline holds a tide. The world is a weather, a wind upon a wind, a veil that is 1,000 veils thick. Cloud tops glitter like frost when sunlight glances across their peaks. Each bright patch marks the crest of an upwelling, a place where vapor has been lifted, cooled, and crystallized into intricate aerosols of ammonia and water. Between the bright crests lie the sunken troughs of descending air that grow dark, as if they had swallowed dusk. From a distance it looks peaceful, like a tapestry viewed from a gallery floor. Close in, the fabric reveals teeth. Edges curl, spirals twist, vortices clutch their neighbors and pull. Tiny filigrees tear free and roll away as newborn storms. The whole plane of vision is alive with turbulence that refuses to rest. Lightning threads the night side, as if the planet had borrowed stars from elsewhere and hid them under its clouds. Flashes bloom inside, towers that dwarf terrestrial thunderstorms, white cores that momentarily turn the bellies of clouds into stained lanterns. Where sunlight returns, the scars of convection remain. Wisps spread outward in undulating plumes, the memory of heat written in vapor. Every spark is a punctuation mark in a sentence that has continued since the world's first cooling. The grammar is energy, dragged from deep layers by buoyant plumes, hurled back down by gravity, and rewritten by rotation that shaves the planet into bands. Rotation sets the rhythm. The world spins in just under 10 hours, and that speed sculpts the atmosphere into parallel streams that flow east and west with relentless persistence. On the edges of those streams, sheer stretches cloud masses into scrolls and ladders that climb the visible skin. The lines curve because the planet's own turn deflects motion sideways, a quiet hand on every parcel of air. There is no still center. Even the apparently steady belts are only averages that hide 1,000 battles between neighboring currents. Heat rises from beneath. The planet delivers more energy to space than it receives from the far sun, as if a private furnace is smoldering under the blankets. That warmth is a message from its birth, a leftover glow of accretion and compression that has not yet finished its long exhale. It stresses the lower layers of gas until they swell and reach upward, then condense and rain their chemistry back down. This is not a thin weather. It is weather stacked to impossible depths, a column of churning air so tall that human imagination mistakes it for a wall. In truth, there is no wall. There is a corridor without floor, pressures climbing with every step inward, until even the concept of a cloud dissolves into something else. Patterns emerge and then betray the eye. Ovals of different colors march along certain latitudes like caravans that never halt. Some live for years, others are born and swallowed within weeks. Wave trains ripple along the edges of belts, their crests aligned for the length of a hemisphere, sculpted by unseen balance between gravity, stratification, and the planet's spin. Brown barges open as if a curtain has been pulled aside to reveal deeper layers. White ovals nudge each other until one wins the slow game of survival. A giant crimson wound stares outward like a permanent hurricane. Even that is only an eddy in a grander sea. Beneath the theatrical top, ammonia snow falls through shafts of rising air, coating colder parcels with ice and altering their buoyancy. Water condenses at deeper levels and builds towers that carry electrical charge. Hail the size of boulders, forged from water and ammonia slush, may grow in those shafts before melting and sinking. Chemistry becomes weather, and weather becomes chemistry again, the cycle knitting itself into larger structures that span the planet. Each loop tightens the mystery. What appears simple at the top asks complex questions below. Where does this power gather? Why does it organize into bands? How far downward does the violence reach? This is not a globe content with symmetry. The poles host cyclones arranged in artistic rings, each vortex gripping the next through a subtle exchange of vorticity. They rotate like jewels set in invisible sockets, persistent yet never identical, as if a painter returned nightly to nudge each shape. At the equator, waves ride westward and eastward at different depths, crossing like whispering crowds that never meet. Along some latitudes, the air zips forward at hundreds of kilometers per hour, then slows only to rejoin the race further on. The eye searches for a stable map and finds instead a living calculus. Shadows of the planet's 6 moons glide across the cloud tops like ink stains. Each transit marks another clock. Tidal pulls tug at the atmosphere, stirring faint tides of gas that slip under the larger drama almost unnoticed. Dust from impacts drifts downward and is swallowed by the moving bands, leaving traces that vanish as quickly as they appear. Even ring material, faint and fragile, sometimes leaves fingerprints in the high air. All of it disappears into the churn, consumed by a weather engine that forgets nothing and remembers nothing, only acting in the present tense. If there is quiet, it lies not in the winds but in the profound pressure of the layers below. Imagine a descent that never finds ground. With each kilometer, the air becomes denser and warmer, until hydrogen and helium that began as gentle gases take on the attitude of liquid. Molecules crowd. Bonds form and break. The familiar notion of a sky lifts away like a costume. The traveller would not witness a line between cloud and interior. Instead, cloud becomes fog, fog becomes fluid, and the fluid grows heavy under its own weight. If one could listen there, the sound would be a bass note drawn out without end. The planet's face shows scars of impacts from comets that dared to dive inward. Dark bruises appeared in the belts after those encounters, then smeared and faded as the winds folded the stains into themselves. The atmosphere accepted even that violence and converted it into new patterns. Nothing that touches this world remains what it was. Even light is edited by the haze, scattered and filtered into pastels that hide the brutal kinetics below. The beauty is a true mask. It does not lie, but it does not confess. Electric curtains crown the poles where particles crash into upper layers and coax them to glow. These auroras flicker like signal fires that never go out. They indicate channeling, a path for charged streams that wrap the planet in a cocoon of magnetism. The glow at the top hints at the moving depths, the way a blush hints at a heartbeat. But the casual glance cannot see through. The veil retains its dignity. It keeps its counsel and forces observers to learn patience. Across eons, storms have risen, fed, merged, and declined. The massive red vortex that holds human attention is both survivor and storyteller. It swallows smaller eddies and sheds long streamers that arc away like comet tails. Instruments track its edges and find skyscraper cliffs of temperature and composition, boundary layers where air that has traveled thousands of kilometers finally meets a different regime. The vortex talks in thermals and colors, revealing only what the surface can reveal. Somewhere below, the roots of its power must dive into depths that the eye cannot follow. The invitation is not gentle, it asks for humility. The cloud tops are not a ceiling on a familiar world, but the uppermost foam on an ocean that continues. The scale defies impatience. The energies ignore the wish for simplicity. Any true answer will arrive only after the atmosphere is read, like a long poem, line by line, cadence by cadence, until the mind senses the meter and learns to travel with it. The first lesson is acceptance. There is no surface to step upon. There is only descent, pressure, and the layering of motions too broad for ordinary language. Beneath the clouds stands a cathedral without pillars, made of gradients and currents, lit by lightning and warmed from within. It waits, unhurried, while watchers gather their courage. A winter night in 1610 found a Florentine mathematician tilting a small telescope toward a bright wanderer. Glass and patience turned a cold spark into a disk, and 4 new points of light huddled nearby. Night after night, the points changed places, slipping from one side of the disk to the other as if circling a campfire. The observer wrote their motions in careful columns, and a secret unfolded. That wandering star had its own retinue, a miniature system in orbit around a giant. The revelation shook the architecture of certainty. and planted a question that would not leave the mind. If moons could circle a planet, what else could hide in that softly glowing globe? Word travelled with ink and whispers. Larger lenses followed, built by hands that learned to tame aberrations and steal a little more clarity from starlight. Through them, the disk showed bands, not a single colour, but alternating strips of brightness and shade that girdled the world. The belt seemed to shift in width and tone, and from time to time a dark knot or pale oval appeared, and then wandered along a latitude like a ship in a current. Observers sketched what they saw with obsessive fidelity, filling notebooks with storms drawn as tiny taps of the pen. The act of drawing trained attention. The more faithfully each swirl was rendered, the more intricacy appeared the next night. In the 17th century, a stubborn oval came into view, a ruddy wound that would outlive empires. Those who tracked it learned patience measured in weeks and seasons, charting its drift and size and colour as if it were a living creature with moods. The meticulous labour of timing its transits across the disk taught a simple lesson that was not simple at all. This was not a frozen pattern. It was an atmosphere with the stamina to hold a storm larger than a world and the caprice to reshape its own stripes again and again. The telescopes grew, mirrors replaced lenses. Mounts learned to follow the planet across the sky, with a motion as smooth as breathing. Spectroscopes scattered the light into rainbows and let the very gases speak. At first, the rainbows only admitted the obvious. There was sunlight reflected from cloud. There was faint glow from the planet's own warmth. Then lines appeared that did not belong to the sun, signatures of molecules that swam in the high air. The identification of methane and ammonia turned colour into chemistry, and chemistry into a clue about pressure and temperature in unseen layers. The planet ceased to be a mere canvas of storms. It began to feel like a laboratory where hydrogen, helium, and trace compounds played out their quiet arguments in slow motion. Radio ears opened in the middle of the 20th century. An unexpected crackle arrived from the direction of the giant, and the static contained a rhythm that changed with rotation. Long wavelengths revealed something unimagined by visual observers. The world possessed a magnetic personality strong enough to blare across space, and that voice was modulated by the dance of a volcanic moon. Bursts of radio noise spiked when the moon took just the right position. Whispering of charged particles guided along invisible lines into the polar skies. Magnetism meant movement in the deep, a conductor turning within. The first machines sent in greeting were metal dreams with foil skins. Pioneer 10 crossed the asteroid belt and faced the radiation that guards the giant like a stormy moat. Instruments tasted the charged particles and counted the blows. Cameras returned portraits of the spinning face, crude by later standards, exquisite by the measure of a human hand that had not yet touched such a place. Pioneer 11 followed, to sound the near space above the cloud tops, to map the magnetosphere's breadth, and to glimpse the rings as a thin whisper of dust, too faint for ground eyes. Voyager arrived in a cascade of speed and timing perfected by celestial mechanics. The twin craft threaded the gravity of outer worlds like skilled sailors leaning into wind. As each flashed past, the planet filled their frames. High-resolution mosaics stitched together belts with ovals curled within ovals. Cloud-tracked winds could be measured by marking features and watching them slide across the meridian hour by hour. Lightning was seen in the night side, bright pinpricks scattered through great towers of cloud. A faint ring revealed itself as a lean hoop around the equator, its particles faintly aglow in forward-scattered light. A volcanic moon proved wildly alive, hot plumes lofting sulfur and rock into space, feeding the magnetic environment with fresh ions. Every image trained the eye to understand that bands were not paint but currents, not static patterns but flows with depth. The next emissary stayed. An orbiter settled into the long practice of looping and revisiting, turning the planet into a place that could be watched, not just glimpsed. On a chosen day, a conical probe separated and dove into the clouds. It carried a parachute, a battery, and the hope of direct contact with the air. The entry heat shield charred and fell away. Sensors drank the atmosphere, sampling temperature, pressure, composition, the speed of winds. The chute dragged the little craft through layers that had only been inferred. Ammonia registered. Helium's fraction whispered of how much of the lightest element still swam there. Wind speeds shocked, remaining strong far below what intuition suggested. Water frustrated predictions, a reminder that a single plunge could land in an unusual meteorological region and tell a story that was local rather than global. The radio signal finally faded as the pressure climbed beyond the probe's courage. Even the failure to reach deeper was a measurement, a bracket around what the environment demanded. Spacecraft not bound for long study still paid court at high speed. A Saturn-bound machine swung past and watched lightning flash in silhouette under the Terminator, capturing frames that froze bolts illuminating cloud mountains. A Pluto-bound traveler used the gravity well as a sling and, in passing, mapped storms with a fresh camera and timing. Each flyby added a layer to the portrait. Another angle, another phase of the planet's long moods, another way to align models with reality. Above air and beyond the blur of Earth's turbulence, an orbiting telescope painted the belts and zones with ultraviolet and infrared palettes. Band by band, the upper haze could be weighed and its particles sized by how they scattered light. High-altitude plumes were caught in mid-bloom. Dark clearings opened windows down to warmer levels that glowed in thermal infrared. Those windows were precious, for they revealed temperatures at depths otherwise invisible, and by mapping temperature, one can map wind and stability. On the ground, glass took a leap forward when engineers taught mirrors to flex against the blur of the atmosphere. Adaptive optics turned large telescopes into near spacecraft, ironing out the twinkle and sharpening the planet into knife-edge clarity. Amateur observers, armed with fast cameras and clever software, joined the enterprise, stacking thousands of quick frames into images rich with detail that once demanded professional instruments. The worldwide community became a net, catching transients, flagging changes, sending alerts that guided larger facilities to act. Microwave radiometers stepped into the story, designed to listen at wavelengths that slip through the top decks of cloud and bring back a sense of what lies below. Brightness temperatures at these frequencies respond to ammonia and water deep in the weather layer, revealing upwellings and downwellings far beneath the visible. Patterns emerged that did not copy the cloud tops, proof that the planet's personality changes with depth. Gravity measurements, refined by careful tracking of spacecraft motion around the planet, mapped the interior's mass distribution with delicacy, turning tiny tugs and drifts into hints about the movement of material within. Piece by piece, the image evolved from pretty to precise. The motives for the bands, the endurance of the great oval, the shape of the magnetic field, the odd glow in the infrared on the night side, the whisper of rings, the crosstalk with moons, all fed a lattice of understanding that did not replace mystery but framed it. The timeline of discovery became a staircase of better questions. Glass taught that the world was striped and restless. Spectra taught what breathed in the air. Radio taught of a magnetic cocoon. Probes and orbiters taught that depth is not gentle and that local weather can mislead global assumptions. Adaptive optics and space telescopes taught that fine detail matters, because the atmosphere speaks in filigree. In that patient climb, wonder remained. Each new instrument made the giant less remote and more complex. The urge to go deeper gathered as calmly as the planet's own slow heat. The cloud tops stopped being a ceiling and turned into an invitation written in data, asking for descent, for maps of hidden currents, for the courage to infer the shape of a world without a shore. Discovery became the art of listening to a storm from a distance and hearing in its voice the outline of the ocean that carries it. A rule set long ago imagined a simple giant: take hydrogen, add helium, press them into a globe, let sunlight glaze the top, and watch a placid atmosphere drift in circles like a lazy river. The expectation was a body that radiated roughly what it received, a soft rotator under a mild sky. The true planet refused that script. Measurements of heat showed a surplus leaving the world, as if an ember glowed beneath the clouds and would not cool. The numbers read like a confession of hidden fire. Internal energy lifted gas from depths, built towers of convection, and fed a weather that needed no gift from the distant star. The The surprise did not end with warmth. Rotation shattered intuition. A day that barely reached 10 hours wrapped the globe in centrifugal insistence, flattening the poles and bulging the waste until the shape itself became a clue. Equations had to bend. The giant was not a slow lantern. It was a whirlpool lit from within. Winds refused limits. At Earth, jet streams live aloft, limited by layers and mountains and continents that break their run. Here, nothing stood to interrupt. Bands raced east and west in broad lanes, their speeds approaching values once considered fantastic. The surprise deepened when tracking revealed that the lanes were not merely skin-deep. It was as if a stack of rivers poured in opposite directions, one above another, each guided by a balance of rotation, pressure, and buoyancy far below what eyes could see. Models accustomed to neat separation between weather and interior had to concede that the separation barely existed. The atmosphere was not a coat, it was part of the body. Composition unsettled expectation as well. In a disk of ancient gas around a young sun, hydrogen and helium dominate and heavier elements appear only like seasoning, yet the giant carried an enrichment of heavy material beyond the naive average. Carbon, nitrogen, sulfur, noble gases, the whole bouquet that shapes chemistry at low temperatures, all seemed more abundant than the bland blueprint suggested. The pattern implied a history of captured ices and pebbles, of fragments piled into a seed that drank the nebula. The idea of a pure gas sphere had never been quite true, but the scale of the departure insisted on a more complicated childhood than a simple inhalation of hydrogen and helium. Enrichment meant processes that sort, gather, and mix. It meant ancestry. The helium story spoke in riddles. When spectrometers and direct samplers tried to weigh helium against hydrogen, they found a shortfall in the visible layers. The scarcity did not fit any picture of unbroken mixing. A plausible culprit emerged in the form of helium droplets forming at depth, separating from the hydrogen mixture as pressures and temperatures crossed a critical line, then raining downward like metallic dew. Such rain would carry energy as it fell, warming layers below while starving the upper atmosphere of helium and certain trace gases that hitchhike with it. The gas giant thus hosted weather made from immiscibility itself, an alien version of precipitation powered by quantum rules. Rain as heat source, rain as alchemist. The upper air told the tale by what it lacked. Then there was the matter of storms that refused to die. A hurricane on Earth fades once cut off from warm ocean fuel or routed over land. On the giant, vortices could survive for decades and longer, merging and splitting, growing and shrinking, living at the pleasure of a shear profile and an energy gradient measured in planetary scales. The most famous eye stared outward, with a diameter that could swallow worlds and with a persistence that mocked familiar cycles. Rules learned from terrestrial weather gave hints, but not answers. Without a surface to kill the spin, without continents to scrape momentum away, the engine ran on principles that needed fresh framing. The lifetime of a vortex ceased being a forecast problem and became a physics lesson in a new regime. A magnetic field complicated the picture. There was no modest dipole neatly aligned with the rotation axis. Instead, the magnetism emerged as a jungle of irregular strengths and patches, a map that looked hand-drawn by forces in turmoil. Only a conductor in motion can create such a field. That conductor could not be ordinary water with salt as on a smaller world. It had to be hydrogen crushed until electrons began to wander freely, a state that shares behaviors with metals. The emergency of metallic hydrogen would be Act 1. Act 2 would be motions within it that did not settle into a gentle, symmetric dynamo. The rules of planetary magnetism, drafted with Earth as the reference, had to admit the behaviors of a different material under a different rotation rate and a different heat flow. The result was a magnetosphere that blasted radio waves, gathered charged particles in belts of fury, and lit polar skies in displays that never slept. Gravity itself added shock. A passing spacecraft felt tiny tugs as it skimmed certain latitudes, tugs that betrayed subtle asymmetries inside. From these whispers of motion, scientists built coefficients that describe how mass is arranged under the clouds. The values refused the simplest solutions. Instead of a tidy core of rock and ice under a clean mantle of fluid, hydrogen, and helium, the data were happier, with a diffuse region of heavy elements, a swollen heart diluted into the surrounding envelope. Such a structure could form if a youthful giant had swallowed a large impactor, or if a primordial seed had eroded with time, its boundaries blurred by deep convection. The old blueprint of a sharp core had to share the stage with a gradient rather than a boundary, a smear rather than a stone. Water teased and scolded. Instruments sought it as a benchmark for the mass of heavy elements and the depth of moist convection. In situ, sampling discovered less than predicted in one place, a result that could not represent the whole unless models were very wrong. The difficulty was a lesson in how uneven the atmosphere might be. If downdrafts had dried the sampled column, or if the planet hosted belts where volatiles gathered or fled, then any single probe would tell a local truth that did not hold everywhere. Radiometers that could see deeper, using microwaves, complicated matters further, revealing bright and dark zones that swapped expectations about where ammonia and water should concentrate. The rules of uniform mixing became suggestions. A three-dimensional reality replaced a one-dimensional simplification. Even the rings refused to behave as mere decoration. Their delicate particles responded to slight gravitational twitches from the interior, setting up waves like the lines that ripple across a drumhead. The ripples gave away oscillations within the planet, subtle global modes that shook the whole body. They acted as a seismograph placed in orbit, and what they recorded argued for a soft internal gradient rather than a hard cutoff between core and envelope. Planetary seismology, anticipated from stars, found a foothold beside a giant. The consequence was not showy, but it spoke against comfort. The models would need to speak in gradients and spectrum rather than in lumps and layers. Heat flux patterns on the disk refused perfect symmetry across latitudes. Infrared maps displayed regions warmer and cooler than pure solar forcing would allow, hinting at upward and downward transport of energy that varied with band. If rising motions dominated in zones and sinking motions in belts, the picture still included exceptions and layered feedbacks that turned generalities into riddles. A top-level white zone might cover a deep column rich in volatiles, while an adjacent brown belt might reveal deeper, warmer gas through a gap in cloud. The sky drew its own topology with chemistry as contour lines, where transparency is elevation and opaqueness is a valley. Familiar ideas about weather cells had to stretch until they covered columns hundreds of kilometers tall. Speed, heat, magnetism, composition, gravity, lightning beyond counting, and an atmosphere with no shore combined into a planet that broke tidy, rules not by malice but by scale. Small world intuition had to stretch until it either snapped or reformed into new mathematics. That transformation brought discomfort and delight in equal measure. A giant of gas is not empty of story. It is stuffed with processes that erupt into new rules when pressure and rotation demand it. The surprise is not that the old rules failed. The surprise is how gracefully new ones arise when nature is asked to perform in a theatre so large. Every new measurement has pointed away from a picture painted in broad, smooth bands. The reality is a field of nested interactions, from droplets that separate out of solution at depth, to electrical currents that braid with flow, to gravity that carries the memory of ancient collisions. The planet looks simple at a glance, because it is expert at hiding complexity in elegant curves. It looks gentle because distance edits violence into pastel. The shock is not a sensational twist, but a gradual insistence that understanding must be earned at the proper scale. When it is, the rules that emerge are not broken. They are rewritten with a heavier hand, using alphabets forged under pressures that crush old words into new ones. A traveler begins where sunlight still has authority. The topmost haze glows like powdered pearl, a veil of submicron particles that scatter blue and ultraviolet light into soft radiance. A breath below, the air cools to a balance point where ammonia crystallizes. Flakes of frozen nitrogen and hydrogen grow on seed particles and drift downward as a pale snow. This is the first recognizable deck, a delicate ceiling whose brightness deceives. It looks thick from afar, yet it is lace. The pressure here would not startle a human instrument, but each meter invites weight, and the fall of temperature with height begins to bend to the will of rising and sinking currents. The descent carries the observer into a region where ammonia snow meets hydrogen sulfide vapor. Chemistry rearranges its loyalties. Crystals exchange partners and form ammonium hydrosulfide, a salt that paints clouds in tawny browns and ochres. The color of the belts owes much to this level, where the mixture curdles into particles with a different appetite for light. Between upwelling and downwelling columns, the heights of these clouds vary by tens of kilometers. Towers rise where warm gas lifts volatiles from depth. Clearings open where dry air descends and suppresses condensation, revealing a warmer glow from below through the gaps. The eye of an orbiting instrument reads those windows in thermal infrared and draws contour lines of temperature that trace the skeleton of convection. Pressure mounts like a drumbeat. Around several bars, water begins to condense. The clouds thicken into mountains that do not touch ground. Here, electric storms are born. Rising filaments carry ice and supercooled droplets past falling graupel and slush. Collisions separate charge. The growing imbalance snaps back as lightning that forks through kilometers of vapor and briefly turns the surrounding cloud into glassy translucence. The bolts carry more energy than terrestrial cousins, and their flashes betray the altitude where they ignite. Sound would be trapped and smothered by density before it traveled far. The light alone tells the story, a stop-motion diary of turbulent towers that reach as if to touch a ceiling that retreats as they rise. Not all precipitation is simple. Ammonia can dissolve water ice, softening hail into slush, and then into a gummy mix that grows as it falls. In the cold heart of a storm, this slush refreezes into dense pellets that carry ammonia downward in secret, then melt at depth and release it far below the visible decks. Such pellets have been called mushballs, a practical name for an alien rain that packages chemistry into ballistic couriers. By hoarding volatiles and relocating them, this process sculpts the vertical profile of gas in ways that confuse a naive expectation of smooth mixing. Columns that once seemed dry in the upper troposphere are not barren. They are participants in a circulation that shuttles material between layers. The rate at which temperature rises with depth is no longer set only by radiation. Convection takes command. Parcels that rise expand and cool. Parcels that sink compress and warm. The resulting gradient hovers near the adiabatic, adjusted by the latent heat released when condensation occurs. The profile matters because it tells how vigorously plumes can rise, how far they can overshoot, and how easily they can trigger new storms along their margins. In belts, where air tends to sink, deeper and warmer layers glow through the thinning cloud and lend the belts their darker tone. In zones where air ascends, bright caps form as ice saturates the upper levels and reflects the Sunday. The interplay does not stop at appearance. It sets up pressure differences that feed jet streams and shear that peels vortices into scrolls. A few dozen bars down, the idea of a cloud deck grows ambiguous. Ammonia has mostly rained out locally. Water clouds deepen into murk. Droplets merge into sheets. The line between vapor and liquid loses clarity as pressure drives molecules into proximity. Hydrogen and helium, once gentle, grow heavy and begin to behave more like a fluid than an air. The distinction between atmosphere and ocean blurs. There is no surface in the human sense, only a continuum in which buoyancy determines which way is up. If a probe were to survive here, it would drift in a twilight sea, shoulders pressed by a weight that multiplies with each kilometer, sensors coated by condensates that behave like fog and rain at once. The chemistry adjusts to new masters. Photochemistry yields to thermochemistry as photons become scarce. Molecules settle into combinations favored by heat and pressure rather than by sunlight's slicing influence. Carbon prefers methane. Nitrogen keeps faith with ammonia unless stripped or shuttled. Oxygen balances between water and whatever reactions the local environment encourages. Trace compounds react on the surfaces of cloud particles, building dyes and chromophores that rise and fall with the cycles of condensation and precipitation. The palette of the planet is not paint on a wall, it is population dynamics for molecules. Deeper still, the hydrogen begins to enter a supercritical state. Traditional boundaries between liquid and gas lose meaning, The fluid carries heat by motion, not just by radiation and conduction, and that motion couples to the planet's spin. Rotation splits vertically stacked currents into slabs that slide east and west. The equator carries a swift eastward flow. Adjacent latitudes answer with counter-running rivers. The shear between them stores energy like a stretched bow and releases it through instabilities that roll up into vortices. Some of those vortices live shallow. Some tunnel downward, rooted in density anomalies that are maintained by composition and temperature. The deeper a jet reaches, the more mass it involves, and the more it sculpts the gravity field that passing spacecraft can measure. At hundreds of bars, helium begins to reconsider its marriage to hydrogen. Under particular combinations of temperature and pressure, the mixture becomes unfriendly to uniformity. Helium forms droplets that are heavier than their surroundings and sinks. Each droplet is a seed of rain, in a world where the raindrops are clear and metallic in spirit. As these drops fall, they release gravitational energy as heat, warming the layers they traverse, and starving the upper regions of helium and the noble gases that once danced with it. The separation creates gradients in composition that suppress vertical mixing through buoyancy effects. The planet's grand weather is chained in part by a quiet drizzle that no eye will ever see. Sound moves faster here than intuition allows. The speed of propagation climbs with temperature and composition, reaching values that change the character of turbulence. Where shock fronts would be rare in a thin air, they become more plausible in a dense fluid stirred by violent convection. Yet much of the agitation is smoothed by viscosity and by the simple fact of enormous scale. Eddies that would roar on a smaller world become murmurs under the weight of kilometers of fluid stacked above them. The theatre is vast enough to swallow its own noise. Heat does not travel evenly. Upwelling columns may carry thermal energy from deeper layers, while nearby regions conduct and convect less efficiently. Differences in tracer abundance, like ammonia and water, mark these pathways. Microwave eyes that listen through the top decks pick up the signature of these imbalances. Where ammonia is plentiful at depth, brightness temperatures fall. Where it is scarce, they rise. The pattern is patchwork rather than stripes only, proof that columns communicate across latitudes and that storms can redistribute material laterally as well as vertically. A descending branch can dry a belt for thousands of kilometers, while neighboring upwells seed towers that tap reservoirs of water rich enough to power lightning for hours. Gravity becomes companion rather than opponent. The deeper fluid lies closer to the planet's center, and the gentlest horizontal pressure differences can drive wide, slow rivers that circle the world. These are not the jets that sketch the top. They are basal currents that carry momentum and heat in deliberate loops. Their existence can be inferred from how the magnetic field wanders from symmetry and from how gravity coefficients refuse simplicity. A map of these rivers is a long project, drawn in tiny changes to the path of spacecraft and in the murmured language of ring ripples far above. The imagined traveler does not find a flaw. Instead, the hydrogen grows dense enough to forget its molecular identity. Electrons begin to move as if in a metal. Conductivity rises. The fluid crosses an invisible threshold and enters a state where magnetism can be generated by motion. At the boundary of this metallic ocean and the molecular layers above, flows shear and fold. Heat rising from deeper regions crosses this boundary and leaves fingerprints in the magnetic field. The path from clouds to core is a ladder of changing physics, each rung altering what is possible for motion, chemistry, and light. At every stage of descent, the planet displays a preference for gradients over walls. Temperature varies with depth and height. Composition changes with storms and with rains that are not water alone. Momentum accumulates in jets that can drill into darker levels or remain trapped aloft. The effect is a world without hard edges, where transitions are drawn out over hundreds of kilometers. Such softness is not weakness. It is an engine that can run for billions of years without fatigue, constantly rearranging its inventories of heat and material to accommodate the demands of pressure and rotation. What lies beneath the bands is not a secret chamber but an expanding vocabulary of states. Snow gives way to slush, slush to hail, hail to supercritical brine, brine to conducting fluid. Each word is a way to say hydrogen more precisely, to acknowledge that a simple element can inhabit many lives. The descent is a lesson in patience, a recognition that science often proceeds by layering subtlety rather than by discovering a single hidden door. The atmosphere is a path, not a mask, and every step inward insists on a new definition of cloud, storm, and sea. A single eye rotates in a canvas of bands, an ellipse the color of rusted sunrise. It does not blink. It surveys a latitude where two jet streams race past in opposite directions, a corridor of shear that both confines and nourishes it. The vortex spins anticyclonically, a high-pressure mountain in a world of airy seas. Its winds circle at hundreds of kilometers per hour, fastest near the rim, calmer toward the center, like a great amphitheater where the outer steps are crowded with haste and the stage waits in a slow spiral. The shape is not quite a circle. It stretches along the flow, a sign that the surrounding jets tug at its edges as a river flattens a whirlpool against a bank. Temperature maps paint it as a thermal plateau. The upper layers run cold because air has been lifted, expanding and cooling as it climbs. That lift builds a dome that rises above the neighboring belts and zones, a summit of gas rather than rock. Around the rim, air descends and warms, creating a bright collar that glows in infrared like a hot ring left by a missing coin. The contrast breeds turbulence at the boundary. Filaments peel away and curl into smaller eddies that either feed the parent or are shredded and forgotten. Energy finds its way inward by this dance of theft and gift, a transfer from the broad jets into the vortex interior through entrainment of sheared ribbons. Color secrets lie in chemistry. Within the cold summit, ultraviolet light cooks trace compounds into complex organics that stain the aerosols with reds and browns. These chromophores settle through layers and are lofted again by convective breaths, a cycle that refreshes the hue even as the outline changes. The tint is not uniform. It deepens along lanes where high air has lingered and faded, along paths where fresh clearings have opened. Observers reading this palette can infer the age of filaments, like botanists reading rings. The signature says that the vortex is both old and continually renewed, a paradox resolved by the rhythm of transport and reaction. Lightning skulks around the outskirts. The core is stable and dry aloft, but the periphery hosts towers that graze the bottom of the main cloud deck, drawing on pockets of moisture that approach from neighboring regions. When these towers collide with descending air, they shed charge and flash, short-lived scars that trace the mixing zones. Each bolt is a sentence fragment in a longer speech about how the storm exchanges mass with its world. The center remains a place of smooth spirals and high clouds. The rim is a workshop of intermittent violence that shapes the long life. Depth is the question that turns curiosity into resolve. Small storms live shallow, large ones root below. Microwave eyes tuned to frequencies that pass through the top decks reveal a signature that stretches beneath the visible oval like a shadow in warmer layers. Gravity measurements taken as a spacecraft skims past show-minute changes in speed that betray a mass anomaly associated with the swirling column, faint but real. Together, these hints suggest a structure that reaches well below the cloud caps. A tower more like a stump than a leaf, married to the layers where water and ammonia sway the buoyancy. The deeper the roots, the harder it is for frictionless flow to strip the vortex away, because the storm becomes a creature of inertia, as well as of surface shear. The lifetime of this eye has not been static. Records of size and shape show a long contraction, a slow tightening from a giant that once sprawled to a compact ellipse that still dwarfs continents. As the diameter shrinks, the rotation sharpens. The storm spins faster in places, and its edges grow steeper, like a skater pulling in her arms. This change does not mean decay without remedy. Vortices that approach can merge with the main oval, delivering new angular momentum. Even without mergers, the jets continue to shear at the boundaries, and that shear feeds the interior through instabilities that act as siphons. The balance between loss and gain writes the present size in the sky. Dynamics within the eye explore a symphony of waves. Rossby waves roll along the edges where vorticity gradients are strong, Gravity waves rise and fall in response to buoyancy, their crests and troughs shaping the fine texture of clouds like ripples on a pond. Kelvin waves hug the boundary, traveling along the circumference like a whispering gallery. These modes matter because they move momentum and heat, deciding where the vortex breathes in and where it exhales. The eye is not a static pool. It is an orchestra of patterns that superpose and cancel, a living interference pattern driven by rotation and stratification. No land waits to sap the energy. No coastline drags on its skirt. The only arresters are the surrounding currents and the slow bleed of energy across scales. At small scales, turbulence breaks features into filaments that diffuse and vanish. At large scales, planetary waves tap the structure and carry energy away. The jet streams act as fences, reflecting some disturbances, transmitting others, and shaping the diet of vortical morsels that the eye can eat. When the shear alignment favors feeding, the storm fattens. When it opposes, the storm thins. The history of the eye is a long ledger of such transactions. The vertical composition inside the vortex differs from its flanks. Air lifted into the summit depletes the upper levels of condensable gases. Ammonia and water find themselves trapped below, shielded by cold layers that suppress fresh convection. The clearing effect opens windows through which deeper warmth shines, but those windows are offset from the cold core and often live in the collar where descending air dries the column. Microwave brightness patterns trace these corridors in looping arcs around the eye, revealing hidden freight lanes for volatiles. The storm is a sorter of molecules as much as a spinner of winds. There is geometry in the flow that charms any mind trained by fluids. The eye wall is a ring of horizontal shear, where velocity changes rapidly with distance. On one side, the air races eastward with a jet. On the other, it races westward with its neighbor. Between them, the vortex stitches a compromise, and that seam is never tidy for long. Filaments detach and slide downwind, sometimes curling back in to strengthen the inner rotation, sometimes wandering off to become independent ovals. The act resembles a baker folding dough, distributing yeast evenly through a mass that then rises as a whole. In that analogy, the yeast is vorticity, and the rise is structure that resists dispersal. The storm does not drift freely. It wobbles along its latitude because the two jets that bound it have personalities that vary with season, solar heating, and internal forcing. When the northern current strengthens, it shoves the eye southward. When the southern current wakes, it nudges the eye northward. The result is a slow meander that traces a narrow path. This confinement helps endurance. The vortex remains where the diet is reliable and the shear manageable, like a predator holding territory near a river that never dries. Auroral particles rarely reach this domain, yet the global magnetic environment still influences the energy balance subtly. Currents that flow in the ionosphere above can deposit heat at high latitudes, altering temperature gradients that eventually migrate equatorward through a chain of circulations. Those shifts change jet strengths, and thus the buffet offered to the eye. The connection is long. It exists nonetheless, another example of how a giant planet turns local weather into a node within a system that stretches from pole to deep interior. A thought experiment imagines a probe passing overhead with sonic instruments tuned to hear pressure waves. The telescope of sound would register low-frequency oscillations from giant eddies bumping and grinding along the rim, a bass thrum punctuated by higher notes from gravity waves breaking at the cloud top. Such a symphony would vary with the orbital day, louder when fresh intruders approach, quieter when the eye consolidates. If instruments could endure long enough, they would detect a rhythm in the feeding and fasting, a metabolic cycle of a storm that has learned the economy of immortality. In the end, the vortex is a teacher of restraint. It shows that persistence can arise from balance rather than from inexhaustible fuel. It survives by placing itself where flow will carry food to its mouth, by turning shear into sustenance, by cooling enough to develop its own coloration that protects and shades, by sinking only where sinking helps, by rising only where rising sustains. It is a design discovered by nature and revised with every filament shed and every eddy swallowed. Beneath its calm center, the layers turn with patience, and the slow pulse of the planet's warm heart reaches upward as a whisper that can be felt in the spiral of clouds. A spacecraft settled into a polar ballet, slicing through invisible curtains of radiation and night, then skimming the cloud tops with the closeness of a whisper. Each perijove became a listening session. The instruments did not seek photographs alone. They wanted murmurs in gravity, shades in microwave glow, tilts in magnetic lines, and flickers in the auroral crown. The motion was deliberate. A long ellipse lifted the craft far out, where the planet shrank to a marbled coin, then hurled it inward for minutes of precision over the belts and zones. From that rhythm, a portrait emerged that was not a painting but a score. The gravity experiment relied on timing as clean as a heartbeat. A radio signal linked the spacecraft to Earth, and any tug from hidden mass shifted the beat. As the craft rolled past different latitudes and longitudes, tiny accelerations wrote numbers that could be turned into gravitational harmonics. Even terms traced the oblate shape, the flattening imposed by rapid spin. Odd terms, once expected to be hushed, rose with meaning. They revealed that wines do not confine themselves to the paint layer. Eastward and westward flows reached down thousands of kilometers, thick enough to grip gravity and leave fingerprints in the coefficients. It was as if invisible rivers had been weighed without ever being seen. A microwave radiometer peered through clouds at 6 wavelengths, each tuned to different depths where ammonia and water control opacity. Brightness temperatures mapped an interior weather that diverged from the view in visible light. Zones rich in ammonia cut cool pathways into the deep. Belts often ran comparatively dry and showed higher microwave brightness, but exceptions abounded. Lanes curled where upwelling transported volatiles and adjacent subsidence erased them. The map refused a simple story of symmetric bands. Instead, it sketched a braided circulation that bound the equator to mid-latitudes and tied storms into the transport of material like veins in a living tissue. Magnets revealed their secrets under the guidance of a vector magnetometer. Instead of a tidy dipole slightly tilted, the field sprawled in patches and gradients. A region of unusual intensity near the equator earned a nickname that suggested color rather than strict spectrum. This anomaly shifted over the years, a sign that the dynamo underneath did not idle in perfect symmetry. The magnetic field seemed to arise from shallow depths compared to other planets, as if the conducting layer that hosts the dynamo had boundary currents tangled near the top of the metallic hydrogen ocean. The field's map grew into a quilt of highs and lows that required flows with complex geometries where conductivity changes rapidly with depth. The poles offered their own theatre. Ultraviolet and infrared spectrographs looked into ovals of ghostly light where particles rained along magnetic field lines and sparked with the upper air. The emissions waxed and waned with rotations and with inputs from volcanic moons that fill space with ions. Alongside the auroras, mosaics of cyclones turned like gears. At one pole, a central cyclone wore a crown of circumpolar companions arranged in a polygon, each vortex holding station through mutual balances of flow and vorticity. The other pole displayed a different arrangement, a reminder that symmetry is a preference that nature entertains only when it must. In these structures, the atmosphere revealed how rotation, stratification, and planetary scale cooperate to build shapes that can persist for years. A camera designed to teach the public with color also served science by tracking clouds near the limb and along high latitudes poorly seen before. Thin blue hazes clasped the terminator. Small storms nipped at the edges of broader flows and left filaments that undulated and snapped back. The camera's rhythm, tied to the craft's rapid polar swing, captured features from a different vantage than equatorial orbiters had managed. Sequences of close flybys traced the life of ovals that merged and reformed, and of plumes that burst from belts with the urgency of geysers. Within the data lay a clue about the heart. Gravity solutions that fit best preferred a core, not compact and stone-tight, but a diluted region where heavy elements are spread through a substantial fraction of the planet's radius. The inference hinted at a more complicated beginning. Perhaps a large embryo ploughed into the young giant and dissolved. Perhaps the original seed eroded as convective motions stirred its boundaries for eons. A fuzzy heart alters how heat moves, how composition stratifies, and where the dynamo can thrive. The craft did not see the core. It sensed a faded border rather than a wall. Microwave paths across the equator found a belt of extraordinary uniformity in certain passes, a ribbon where ammonia distributions and temperatures lined up with the elegance of a metronome. Elsewhere, the instruments felt the chaos of lumpy convection and patchwork chemistry. The blend said that some latitudes host deep, organized flows that are less prone to storms, while others harbor vast regions where moist convection injects parcels upward and drags condensables down in a circulation that never tires. The complexity demanded models that can balance rotation, latent heat, and deep stratification without relying on simplified caps or bottoms. The dynamic of the Great Blue Spot in magnetism and the polar cyclones in meteorology offered lessons in timescales. Magnetic features evolved over years, implying shear and advection at depths where conductivity is high but flow speeds are restrained. Cyclone polygons held their shapes with only slow drift, indicating a fragile balance between mutual rotation and the background jets. Meanwhile, small storms at mid-latitudes bloomed and died within weeks. The planet offered a gallery of changes paced from days to decades, all interwoven and all leaving their marks in instruments tuned to different senses. Jovian lightning at low latitudes appeared rarer than at higher ones. Microwave and optical detections suggested that energetic towers bloom more often in zones where convective inhibition is lower. The equator, with its peculiar balance of shear and stability, presented fewer opportunities for such towers to climb. This pattern resonated with the idea that moist convection and jet architecture conspire to paint the map of power. Even in a world with no land, geography matters. Geography here is pressure and stratification, not rock and valley. In situ, radiation monitors endured torrents of energetic particles and mapped belts that stretch and contract. Some electrons ride along magnetic shells that dip closer to the atmosphere in spots where field lines twist. Their energy feeds auroras with a menu that changes with solar wind pressure and with the rhythm of volcanic supply from the innermost large moon. The spacecraft learned to pivot its solar arrays and adjust its attitude to survive passages that could cook hardware. Every safe pass added another layer to the maps of charged weather surrounding the mechanical heart of the planet. The orbiter played conductor to a worldwide orchestra of telescopes. When the camera saw a plume, alerts went out. Infrared eyes on Earth and in space searched for the heat mark. Radio observers tuned for changes in non-thermal emission that might hint at charged particle injections or wave activity. Amateur astronomers stacked thousands of frames into crisp slices of the disk, catching the first moments of new outbreaks and marking their drifts. The combined view placed the spacecraft's narrow path in a wider context, turning single flybys into chapters of a continuous story. Laboratories on Earth supported the mission by recreating pressures and temperatures in anvils and diamond cells. Hydrogen compressed until it surrendered electrons to mobility. Helium coaxed into separation from hydrogen at relevant conditions. Water forced into exotic phases that blur lines between ice and fluid. These results informed interpretations of measured fields and flows. When the magnetometer found a patch, modelers asked how a gradient in conductivity at the top of the metallic layer would sculpt such a feature. When the radiometer drew a dry belt through the deep, chemists asked how mushball rain could drain ammonia from that column and keep it rare. As the spacecraft counted close passes, it tilted the language of uncertainty. The jets extend roughly 3,000 kilometers beneath the visible. The magnetic field is born in a shallow metallic sea compared to later expectations. The core is likely diluted. Ammonia forms broad plumes and deserts at depth. Polar cyclones hold court in stable patterns. Each of these phrases began as speculation and grew toward confident description with every new trajectory. None closed the book. All turned guesswork into the kind of knowledge that carries error bars and invites further questions. The greatest gift was connection. Gravity harmonics spoke of deep winds. Microwaves revealed the veins that carry chemical blood. Magnetism traced the nerves in a conducting layer, newly appreciated for its texture. Auroras glowed at the poles where those nerves reached space. Cyclones showed how rotating fluids can build geometry without a blueprint. The craft itself moved like a metronome through this symphony, counting time until the questions could be put in order. The planet did not answer in words. It answered in fields, in fluxes, in brightness maps, in variations that together formed a quiet instruction in how to listen to a world that has never known a shore. At the center of imagination there once sat a stone. A compact kernel of rock and ice was pictured, wrapped in a mantle of hydrogen and helium that had simply fallen inward from a newborn nebula. That stone served as anchor and origin story, the seed around which a giant accreted. Then the numbers arrived from careful measurements of gravity, and the whisper of vibrations felt in rings, and the picture softened. The heart did not read as a boundary. It resembled a region. Heavy elements seemed to be smeared through a vast interior, rich near the center but fading outward in a gradient rather than stepping across a sharp line. The term that rose to describe it was diffuse, or diluted, or fuzzy, and those words were as unsettling as they were precise. A core that is a volume, rather than a lump, changes everything about how a planet stores its heat, stirs its depths, and remembers its birth. One explanation carries the violence of youth. In a crowded nursery of forming worlds, an embryo large enough to boast its own gravity could have plunged inward and been swallowed. The collision would have been less a blow than a drowning. The intruder's rock and ice would not slam against a floor, for there is no floor. Instead, it would sink into a hot fluid and dissolve. Heavy atoms would unbind and spread, thickening the inner envelope. Over time, convection would work to mix the infusion, but convection in a giant is not a perfect blender. Where density increases smoothly with depth because of composition, rising parcels feel an extra weight beyond what temperature alone predicts. That weight resists overturning. The result can be layered convection, thin steps stacked for thousands of kilometers, efficient at carrying heat on small scales while preserving gradients on large ones. Another origin story is slower and quieter. Imagine a world that began with a traditional heart, a tight collection of rock and ice. Above it lay hydrogen and helium that grew ever more burdensome with depth. At the boundary, heat flow and chemical affinity would conspire to nibble at the edges. Solids would dissolve into nearby fluid, first along defects and fractures, then through cracks widened by temperature and pressure. Each dissolved parcel would lighten the heart and thicken the surrounding fluid with heavy elements. Given enough time, the sharp border would blur. The process would reshape the internal profile of density and smooth the transition from composition heavy to composition light. Erosion of a core by the envelope is not an image borrowed from rivers and cliffs. It belongs to a world where matter is pressed until it slips from familiar categories and reassembles under rulings handed down by pressure. Either path, violent or patient, sets a stage for double diffusion. Heat and composition both affect density, but they move at different speeds. Thermal energy diffuses quickly. Molecules responsible for heavy element enrichment diffuse more slowly. When a warm, heavy parcel rises, it loses its thermal advantage faster than its compositional disadvantage. It stalls and spreads, forming a layer. When a cool, light parcel sinks, it warms rapidly but retains its lightness. It too forms a layer. Stacked together, these steps create a staircase that moves heat upward less efficiently than a single overturning convection cell would. The interior breathes through many pores rather than through one wide throat. Such breath can prolong a planet's internal glow for eons and change the way heat gradients feed the flows that shape magnetic fields. A gradient in heavy elements also shifts where a dynamo can thrive. Conducting hydrogen requires motion to generate magnetism. Motion is constrained by buoyancy. If composition locks deep layers in place, the most vigorous flows may gather in a shell above the gradient, where convection is freer. The resulting magnetic field would then carry fingerprints of the geometry and thickness of that shell. A lopsided or patchy field at the surface hints at sheared flows in a conducting layer that is neither uniform nor deep to the center. The field becomes a map drawn by moving metal guided by boundaries written in composition as well as by temperature. The fuzzy heart touches the heavy element budget in a practical way. Enrichment of oxygen, carbon, nitrogen, sulfur, and noble gases tells how much material colder than hydrogen and helium resides within. Those atoms can be delivered by pebbles, planetesimals, or dissolved impactors. A concentrated core requires less enrichment of the envelope to match a given total. A diffuse core invites more mass in heavy elements mixed throughout, changing the mean molecular weight across wide regions. The change affects sound speed, and thus the spectrum of global oscillations, which rings translate into waves. If rings ripple with certain spacings, they are responding to the deep profile of density, which in turn is a poem written in hydrogen, helium, and the ashes of ices and rock. What appears as softened structure modifies the fate of helium. At depths where hydrogen and helium quarrel over their relationship, droplets of helium condense out of solution and sink. The rain warms the path it falls through and lowers the helium fraction above. If heavy elements are already grading with radius, this precipitation does not fall through a single clean layer. It crosses a composition slope and may pool in zones of similar density, enhancing some steps in the staircase while weakening others. The interplay between helium rain and a fuzzy heart can be long-lasting. It can maintain heat release at a level and a pattern that would be impossible in a more uniform interior. The equations that govern the interior depend on equations of state for hydrogen, helium, water, rock, and their mixtures under conditions that no ocean or mantle on Earth can reproduce. In diamond anvils, samples are squeezed and shocked, their behavior measured as pressure climbs by orders of magnitude. From these experiments, and from first principles calculations, curves emerge that tell how density responds to pressure and temperature. A diluted core demands attention to mixing rules and partial miscibility. If water becomes superionic at certain temperatures and pressures, its atoms arranging in a lattice through which protons flow, then rock-forming elements can ride within phases that behave neither like ordinary fluids nor like solids. Such states change how dissolving proceeds and how fast it can sculpt a gradient. The consequences for storms are subtle but real. A stratified deep interior resists communication with the weather layer except through specific pathways. Where composition gradients are weak, plumes can reach farther, carrying momentum and heat upward that influence jets. Where gradients are strong, plumes stall and spread at intermediate depths, feeding lateral flows that may not announce themselves at the top except as shifts in belt behavior and preferred latitudes for outbreaks. The banded face becomes the canvas on which deep structure paints indirectly, with shades and textures sensitive to layers far below any eye. Formation scenarios must adapt. Pebble accretion, a process in which centimeter to meter-sized fragments spiral inward through gas and are swallowed in torrents, can build a heavy element reservoir rapidly. If the planet crosses a threshold where gas capture accelerates before the core is neatly finished, the final product is a hybrid. Heavy elements are spread into the envelope while an inner concentration remains. Later collisions or continued dissolution can smear the profile further. The final arrangement is a snapshot between histories. It preserves the memory of building blocks while wearing the work of time like patina. In such a world, a simple radius does not tell a simple story. Two planets with identical masses and radii can house different hearts. One may keep most heavy elements packed into a compact kernel. The other may drape those elements in a gradient through half its interior. Their heat flows will differ. Their magnetic fields may weave different patterns. Their response to tides and their gravity harmonics will part ways. Thus, comparing giants becomes an art of interpreting gradients rather than counting layers. The fuzzy core reframes longevity, where a sharp boundary would foster vigorous overturning that erases gradients and discharges heat efficiently. A smooth transition slows the march toward thermal equilibrium. The giant glows for longer. The glow modulates with depth and time, influencing the energy available to drive jets and to feed long-lived vortices. The planet becomes a slow clock, its tick defined by the rate at which heat and composition find paths toward uniformity. Those paths are many, and none is short. Seismology offers a way forward. Global oscillation modes depend upon sound speed as a function of radius, which is set by temperature, composition, and phase. When a planet trembles, even by micrometers, the tremor sends waves outward that can modulate rings or imprint line shifts in spectral signatures. Detecting such modes with clarity turns the fuzzy heart from hypothesis to measurement. In that pursuit, Every ripple in a tenuous ring, every beat in a field of particles, becomes a stethoscope pressed against a chest of hydrogen, listening for the cadence of a gradient. The idea that a heart can be a spectrum rather than a dot invites a different kind of wonder. A gradient does not deny identity, it reveals evolution. The center is not one place, but many radii, with different shares of heavy element memory. Those shares control how buoyant a parcel will be, how fast a wave will run, how readily a current will bend. The story of a giant becomes the story of how a smear holds shape for billions of years while still allowing motion enough to write storms upon its surface and magnetism upon space. Fuzziness, in this context, is not confusion, it is texture. It is the felt grain of a world that refuses to be simplified. Pressure gathers like a dusk that never lifts. Hydrogen, the universe's simplest letter, is pressed into a script it rarely writes. At modest depths, molecules tumble as a warm gas, partnered in twos, colliding and drifting, infrared photons slipping between them like quiet messengers. With each kilometer inward, collisions grow impatient. The gaps shrink, the grammar changes, molecular bonds begin to matter less than the crowding that forces electrons to consider the company of strangers. The familiar line between gas and liquid loses its edge and then its authority. A supercritical fluid takes the stage, dense enough to flow like a liquid, free enough to fill its container like a gas. In that twilight of states, hydrogen prepares to forget that it ever preferred pairs. The change is not theatrical at one sharp altitude. It unfolds across a band of pressure and temperature where the balance tips from molecular to atomic, and then from atomic to metallic. The words metallic and hydrogen seem to deny each other, yet the physics is plain. Under multi-megabar pressures and thousands of degrees, electrons cease to be tied to single nuclei and begin to move through the crowd. Conductivity rises the way dawn saturates a valley, first as a blush, then as a flood. Reflectivity follows. If eyes could see here, they might find a sheen where previously there was only haze. Electrons form a sea, and that sea is the key to the world's hidden magnet. The melting pot for such behavior is hot and restless. Temperature keeps atoms in motion, hammering any crystalline ambition into fluid compliance. The metallic trait arrives not as a crystal, but as a conductive liquid. This ocean is unlike water. It does not wet rocks or lap shores. It occupies shells within a giant that offers no solids to touch. Its currents are not wind-driven. They answer instead to buoyancy, set by heat leaking outward from deeper compression and to the planet's rapid rotation, which stretches rising plumes into columns aligned with the spin. Those columns keep time with an invisible metronome that fixes north and south and softens chaos into organized roll. Electrons moving within this ocean make it sensitive to magnetic influence. Whenever a flow cuts across a magnetic field, the field answers with an induced current. The current, in turn, generates its own field, and if the geometry and speed are right, the feedback sustains a global magnetic structure. The threshold is captured by a dimensionless measure called the magnetic Reynolds number, which compares the tendency of fluid motion to carry the field with the tendency of diffusion to erode it. In the metallic layer, this number can exceed the critical value. The field is not a fossil, it is a living product of motion. Rotation complicates and empowers. In a rapidly spinning fluid, the Coriolis influence redirects motion sideways and encourages the formation of tall, thin cylinders of flow that wrap around the axis like ghostly pillars. These Taylor columns can guide the dynamo by funneling currents and aligning vorticity. Where composition or heat gradients impose barriers, the columns tilt and shear, twisting field lines into new shapes. The outcome is seldom a neat dipole. It is a landscape of magnetic highs and lows, patches where lines converge and diverge, regions where the field reaches upward to graze the atmosphere and carve auroral ovals with stubborn persistence. The metallic layer is not uniform. With radius, the conductivity climbs, peaks, then often falls as the fluid transitions again toward conditions where electrons bind more tightly. At its top, a boundary region hosts a swift rise in conductivity over hundreds of kilometers, thin by Jovian standards, but decisive for dynamics. Zonal winds that glide easily in molecular layers are braked here by the Lorentz force, which resists motion that would bend magnetic lines. The deeper a jet tries to reach, the more it drags field along, the more heat it loses to ohmic dissipation, and the more it slows. The modulation marks a coupling depth where atmospheric patterns hand their momentum to the interior and accept magnetic restraint in return. Helium complicates the brew. Under some combinations of pressure and temperature, hydrogen and helium prefer a partial separation. Droplets of helium can condense within the metallic zone and fall. Each drop is heavier than its surroundings and carries with it latent energy that warms layers below. The rain is transparent, but its effect is not. The temperature structure adjusts, setting where convection is vigorous and where it is muted. The dynamo responds to such thermal scaffolding, strengthening where buoyancy is most generous, retreating where gradients sap its force. The metallic ocean thus hosts rain that changes both chemistry and magnetism, an exchange invisible to any eye. The microphysics within this ocean is a library of extremes. Viscosity sits low, enabling large Reynolds numbers that feed turbulence. Thermal conductivity runs high relative to molecular fluid, yet convective transport still dominates. The magnetic Prandtl number, the ratio of viscous to magnetic diffusion, hovers in a regime that invites tangled fields and nested eddies. In such a setting, small-scale motions amplify local patches of magnetism while larger structures carry the field outward. Reversals and excursions can occur in principle if flows reorganize, though the giant's rapid rotation and steady heat flux favor stability over dramatic flips. The field drifts, reshapes, and meanders rather than overturning. Waves live here that never reach the cloud tops. Magneto-inertial waves combine the elasticity of magnetic tension with the stubbornness of rotation, sliding along cylinders and reflecting from gradients in conductivity. Alphen speeds, which measure how fast such disturbances travel, rise with field strength and density, setting the tempo for how swiftly the dynamo can respond to changes in flow. Where the metallic layer thins or thickens, or where conductivity shifts due to composition, these waves change pitch. The spectrum becomes a diagnostic. If one could hear it, a sonogram of the deep would reveal maps of structure in tone alone. Laboratories try to meet this ocean halfway. In diamond cells and shock compression rigs, hydrogen is squeezed and heated until it refuses to be itself. Conductivity is charted as a function of density and temperature. Reflectivity curves are traced. Equations of state are refined so that models of giants are not drawn from wishful lines but from measured behavior. The experiments suggest that metallization can be gradual at high temperature, an insistent climb rather than a cliff, compatible with a planet that shows no abrupt magnetic shell, but rather a thick womb where field is nurtured. Theory supplements the effort with calculations that include proton quantum effects, electron correlation, and the complexities of mixtures where hydrogen, helium, and oxygen-bearing species speak in intertwined dialects. The presence of a conductor allows other subtleties. As jets above try to slide past, they induce secondary fields that can leak upward into the atmosphere and downward into the deeper ocean. The leakage carries energy as pointing flux and can deposit heat where gradients turn it into work. This is a gentle process compared to the great convective furnace, yet over geologic spans it can shape where the field is patchy and where it is smooth. Regions where conductivity is high but shear is low may host quiet, strong field. Regions where shear gnaws at lines may glow with complex, time-dependent loops. A metallic ocean has a memory for rotation. Fluid parcels aligned with the spin axis resist being displaced across cylinders, a constraint that leads to differential rotation pinned to latitude. But magnetic coupling erodes that freedom with depth. An equatorial superrotation aloft may be trimmed below, while high-latitude flows hand their momentum to field more readily. The result is a profile of wind that fades and shifts as pressure rises, a stratigraphy of motion carved by conductivity. Where metallic behavior begins, the planet's weather meets a break that does not resemble friction against a solid. It is a negotiation with trapped lines of force. Nothing in this sea is still. Heat made by slow contraction and by helium rain rises each day and night without pause. Composition gradients set by ancient collisions or by long dissolution remain, but they blur with time and are sharpened again by continued rain. The field drifts as flows adjust. The atmosphere above leans and tugs through gravity and through the shared pressure of rotation. The total picture is a choreography that persists for billions of years without repeating a single step. Metal has always meant solidity in human hands, echoing with the ring of hammer and anvil. Here, the word means freedom for electrons in a place where nothing else is free. It means a mirror in darkness, a conductor that turns motion into magnetism and magnetism again into motion. The ocean that carries this property is neither near nor far in the ordinary sense. It is the interior's middle road, a realm that mediates between an outer world of storms and an inner world where heavy elements gather. Within it, the planet writes its signature into space, a field strong enough to corral charged particles and paint auroras, subtle enough to reveal by its patches the flows that maintain it. To imagine standing at the edge of this ocean is to imagine no ground at all. The sense is of depth without horizon, warmth without flame, and a sheen that answers to unseen lines. In that answering resides the identity of the giant. It is not only a theatre of clouds, it is also a forge where pressure turns the simplest atom into a conductor of worlds. Nightfall in this realm is permanent. Light belongs to lightning somewhere far above. But the darkness is not empty. It is full of electrons in motion, shaping a magnet that hums with the patience of a planet that refuses to cool too quickly. Bands look like stripes, but they behave like rivers. Eastward and westward lanes run side by side across latitudes, each a stream with its own temperament and cargo of vorticity. The equator carries the swiftest current, a broad ribbon that races sunrise to sunset with ease. North and south, alternating jets answer in counterpoint, narrower and sometimes sharper, as if the planet had carved a barcode of winds into its own skin. The pattern is not painted on. It is a living circulation that ranges in depth, anchored by balances between rotation, pressure, buoyancy, and the slow leak of interior heat. Rotation gives the first rule. Any parcel that drifts poleward finds itself nudged east or west by the planet's turn, an effect that depends on latitude through a parameter that climbs from equator to pole. The result is a preference for flow that organizes into long, nearly zonal currents. Turbulence does not vanish, it reinterprets itself. Eddies born from storms and shear carry momentum in a way that can strengthen the very jets that sheared them. Energy cascades upscale in a rotating world, feeding larger structures rather than dissolving into smaller. The scale at which eddies surrender to jets depends on the rate at which rotation's influence changes with latitude. Where that gradient sets a limit, jets space themselves like rungs on an invisible ladder. Potential vorticity, the bookkeeper of rotating fluids, arranges itself into staircases. Within each step, the gradient is weak and mixing is freer. Across the risers, the gradient is strong and mixing is resisted. Jets arise along the risers, acting as fences that corral traces and sculpt the distribution of clouds and gases. When a filament attempts to cross a fence, it is stretched until it thins and fades, or it is rolled back and absorbed. The belts and zones thus become more than contrasts in color. They are borders and provinces in a nation ruled by rotation. The vertical structure of these streams defies the notion of a thin weather layer. Thermal wind balance binds vertical shear to horizontal temperature gradients. If the north-south contrast in temperature weakens with depth, so must the shear. Observations of radiation and microwaves suggest that contrasts do change as pressure rises, and gravity's whispers imply that the jets reach down thousands of kilometers before fading. In the upper troposphere, the winds run near their maxima, sculpting cloud and transporting condensables. Below, they taper as density climbs and as electrical conductivity grows to a level that begins to resist motion through magnetic coupling. There is no abrupt line where jets end. They dim with depth the way light dims in water. The equator hosts a special regime. Here, waves that feel little of the poleward gradient can propagate along the ribbon and deposit momentum without the usual deflection. Some of these are Kelvin waves, hugging the equator and maintaining their form as they travel. Others are mixed modes that couple buoyancy and rotation. When convection heaves a tower into this environment, it sends gravity waves outward and drifts vorticity into the mean flow, feeding the eastward current. The equator answers by sharpening, its core almost arrow straight, while on either side, narrow westward jets confine it. The result is a central highway that stands apart in speed and stability. Moist convection acts as an engine that injects small-scale eddies at preferred latitudes, often along the borders between belts and zones where ascent and descent meet. These eddies do not randomly scramble the atmosphere. Their interactions with the background shear tend to push momentum up its gradient, accelerating fast lanes and decelerating slow ones. The process resembles a crowd that somehow organizes to push sprinters faster while slowing wanderers back toward the curb. Over time, the jets harden into features that resist change, even as the cloud patterns above them dance through many styles. Jets do not own steady lines. They meander, they spawn waves, and they occasionally shed vortices that drift like leaves caught in eddies beside a river. On rare occasions, a jet reorganizes, shifting its central latitude or splitting into two. Such events rewrite the map of transport, opening corridors for tracers to cross once forbidden boundaries. The aftermath can linger, leaving a belt paler or darker for months, or redistributing condensables that later erupt as storms. The system balances on a knife edge between rigidity and readiness to change. Deep within, where hydrogen thickens and begins to conduct, a different actor enters. The same currents that plow east and west through molecular layers try to reach into the metallic sea. There, the motion drags magnetic lines, and those lines push back with a subtle force that converts kinetic energy into heat. The process does not halt the jets abruptly. It asks them to trade speed for warmth as they descend. The trade is uneven with latitude, because geometry and field intensity vary, and because the angle between flow and field shifts from place to place. In some regions, the break is strong, in others mild. The result is a vertical profile of wind that fades and warps, a signature stamped into the magnetic irregularities that observers read as a map of the dynamo's roof. The poles tell a complementary story. The gradient that guides mid-latitude jets weakens near high latitudes. There, the atmosphere chooses to build gyres more readily than zonal currents. Cyclones cluster into ordered rings around central storms, held in place by a balance between mutual rotation and the background environment. Jets exist, but they are fewer and less dominant, their identities blurred by the dominance of vortical structures. The transition from alternating bands to polygonal cyclone arrays is not a contradiction. It is the same physics speaking in a dialect shaped by latitude. Transport across jets is not impossible, only difficult. Tracers slip through at places where waves break and stir the border. Gravity wave packets launched by deep storms can deposit momentum when they encounter critical levels where the background wind matches their phase speed. There they tilt, break, and shear the flow, opening temporary gates that let material cross. Over time, such gates knit belts and zones into a single global circulation that carries heat poleward and returns it at depth. The jets, for all their power, are walls with doors. Angular momentum offers a global constraint. Air moving poleward must change its spin rate to conserve this quantity, just as a dancer spins faster when drawing in her arms. On a planet that rotates quickly, that change is large. It would generate immense winds if not moderated by pressure gradients that build as flow develops. The balance between these two tendencies defines the jet's amplitudes and positions. Interior heat supplies the energy that keeps the machinery in motion, but geometry and conservation laws decide the shape of the output. The Rhine's scale provides a guide to spacing. It compares the speed of turbulence with the rate at which the Coriolis effect changes with latitude. Where eddies race faster, the scale grows and jets space themselves widely. Where eddies grow sluggish, the scale shrinks and jets crowd more closely. On a giant with strong driving and swift rotation, multiple jets become a natural consequence. stitched across the sphere like chords pulled taut on a drum. Their number and spacing are not arbitrary. They are the imprint of a balance struck by the planet's size, spin, and thermal vigor. Tracer maps in microwave and infrared confirm that jets are not merely crowns on a shallow weather layer. Ammonia, water, and other condensables show desert and oasis patterns aligned with the flows down to great pressure. Some deserts correspond to sinking branches where mushball rain has robbed the air of its soluble load. Some oases mark regions where ascent replenishes inventories and maintains high cloud. The consequence is a vertical architecture in which chemical contrasts reinforce dynamical barriers, and dynamical barriers help sustain chemical contrasts. Feedback binds composition to motion. Even the faint rings serve as distant witnesses. Weak waves curl through their particles with wavelengths tuned to global oscillations. Those oscillations include modes that feel the deep wind field. When the pattern of ripples in ring material is compared with models, it constrains how mass moves beneath the clouds. The match is never perfect, but it sharpens the outline of what depth and strength the jets must claim to fashion the gravity field that, in turn, sculpts the rings trembling. There is patience to the system. Jets can persist for decades with only gradual drift. They remember past outbreaks in subtle ways, through the placement of lingering tracers and through the altered probabilities of new storms. Yet the persistence is not stubbornness without cause. As long as the planet emits more energy than it absorbs, as long as rotation remains rapid, and as long as composition stratification permits layers to talk to one another through convection and waves, the architecture of streams will return after any disturbance. It is the attractor toward which the atmosphere leans. Picture a vertical slice through one latitude. At the top, filigrees of cloud trace shear like chalk on a moving blackboard. Below, the wind profile falls off with depth, knuckled where buoyancy steps resist motion, then smoother in layers that couple freely. Deeper still, conductivity rises and magnetic drag begins to speak. At the base of the weather realm, motions feed slow rivers that circle the planet in shadow, carrying heat and angular momentum like heavy freight. The slice is not the same at every latitude, yet the family resemblance is clear in each. Jet streams that never touch land, never climb mountains, never see a coastline, still find structure and memory. They are sculptures in a medium without edges, shaped by equations rather than terrain. Their endurance is the quiet signature of a world that has found a stable compromise among forces that could be chaos. They braid weather to interior, chemistry to wind, and magnetism to flow. They are the handwriting on the cloud tops, legible if read with patience and with the right alphabet. A planet without a solid crust still carries a map. It is written in lines of force that arch from pole to pole, bow outward, twist, reconnect, and vanish into a tail that reaches past distant moons. The cartography is magnetic, and its glyphs light the sky in curtains that never tire. The field is not the neat bar magnet sketched in classrooms. It is lopsided and knotty, with strong patches and quiet hollows, a quilt stitched by a conductor in motion and stretched by rotation that keeps time like a silent drum. Close to the planet, the field bends tightly. It tethers charged particles and whips them along paths that circle the equator in furious belts. Electrons spiral, mirror, and drift, singing radio songs as they do, their chorus modulated by the planet's spin. Deeper in, the field lines thread air that grows denser with each kilometer until pressure turns hydrogen into a ready conductor. There a dynamo stirs. Columns of warm fluid rise and fall, bent by rotation into long, thin sheets of flow. Where these sheets shear against composition gradients, currents grow. Where currents grow, magnetism replies. The answer is a pattern of hotspots and anomalies that spills outward through the atmosphere and into space, solid enough to be mapped yet restless enough to evolve. Auroras ring the poles in ovals, bright enough to register even under fierce daylight. Some arcs glow steadily, a main ring drawn by currents that enforce near corrotation, a struggle between the planet's rapid spin and plasma that prefers to lag behind. Other arcs burst and ripple. Dawn storms flare like sudden applause. their energy arriving from deep within the magnetosphere, where stretched lines in the far tail snap and fling plasmoids downstream. High above, X-rays flicker as heavy ions crash into the thin air and exchange charge in a brief flare of new identity. Near-infrared emissions paint a separate layer, a lower band where heat and chemistry conspire to write the magnetosphere's influence into temperature itself. A volcanic moon contributes to this theatre, with the patience of geology and the urgency of eruption. It casts sulfur and oxygen into space until a torus encircles the planet, a donut of ions that glows in ultraviolet and feeds the magnetosphere with fresh plasma. Where this moon plows through the field, it drags a wake of alphenic disturbance that races along lines toward the poles. At their footpoints, bright spots appear within the larger aurora, twin beacons that pulse with orbital rhythm. The message is unmistakable. The field is not only weathered by the solar wind, it is driven from within by a factory of particles that orbits in lockstep with thunder below. Radii away from the planet, the field flattens into a disk. Centrifugal forces pull lines outward, and a current sheet forms where polarity flips from north to south. This magnetodisk is a realm of interchange instability, a dance in which flux tubes loaded with heavy plasma trade places with lighter ones. Injections race planetward like beads on a string, carrying energy that later shows itself as auroral intensifications and reconfigured belts. The sheet wobbles with the planet's rotation, tilting and snapping back, a restless hinge between inner control and outer perturbation. The solar wind is an intermittent guest rather than a tyrant, yet it leaves marks. Compressions of the magnetosphere under high pressure fold the field inward, enhancing currents and shifting auroral boundaries. Rarefactions let the magnetosphere swell until the tail reaches afar, sometimes to the domain of a distant moon. Reconnection at the dayside opens field lines to the wind for a time, then lets them close again on the night side, with a thud that travels along lines at Alphen speeds and steps down through the atmosphere as heat and light. The cycle does not rule the system. It spices it with variability that rides atop the engine driven by rotation and plasma supply. The field at the surface is an archive of the dynamo's geometry. It shows places where lines plunge deep with unusual intensity, regions near low latitudes where the equatorial field is stronger than a simple model would allow, and offsets between magnetic and rotational axes that speak of flows not centered on the spin. These features drift with the years, a secular variation that betrays motion in the layer that hosts the dynamo. The speed of change is modest, yet distinct. It hints at slow winds in a conducting sea, shearing an advecting field, the way a river stretches a ribbon of dye. Currents on a grand scale tie the atmosphere to the deep, where field lines intersect ionized layers high above. Charged motion can generate drag that reaches downward through collisions and influences neutral winds. At high latitudes, that coupling warms the air and alters pressure fields that propagate equatorward in subtle tides. The entire planet becomes an electrical circuit with resistors and capacitors arranged in 3 dimensions, energy stored and released along paths that cannot be drawn with a simple pencil. Even lightning in the weather layer adds to this circuit, launching whistlers that slide along field lines, their frequencies stretched by density and distance, signatures of storms heard thousands of kilometers away. Radiation belts test any hardware that trespasses. Electrons at near relativistic energies drift in layers that thicken in some longitudes and thin in others, guided by slight irregularities in the field. Protons join the dance, slower but more dogged. Wave-particle interactions paint and erase these belts, with chorus and hiss altering pitch and intensity as magnetic conditions change. New injections from the magnetodisk inflate the belts, and gradual diffusion thins them, a breathing that matters to the longevity of passing instruments, and to the alchemy of auroras that feed on their edges. Some moons answer back with their own currents. Icy worlds with conductive layers beneath their crusts feel the sweeping of the changing field as induction. Currents loop within hidden brines, generating secondary magnetism that modulates the parent field. Those loops are faint compared to the main dynamo, yet they can be sensed. A small shift in the rhythm of a magnetic pass speaks of an ocean buried under ice, not through image but through arithmetic of field and motion. The labyrinth maps not only empty space but also the interiors of companions. Below the clouds, magnetic drag sets a quiet boundary for the depth of atmospheric jets. As wind tries to extend into the conducting region, it meets resistance. Lines of force, reluctant to bend, push back. Energy extracted from the flow dissipates as heat, a diffuse friction that leaves no surface scar but changes vertical profiles of speed. High-latitude jets fade more quickly or more slowly, depending on the local field. Equatorial flow can burrow deeper, where the field is weaker or differently oriented. This coupling writes patterns into both wind and magnetism that models can compare with measurements until guesses thin into understanding. Waves inhabit the field like travelers along a road. They reflect from gradients in density and conductivity, and they interfere to build standing patterns that color auroral arcs with flicker and swirl. The speed at which such waves run sets a clock for the magnetosphere, a timescale for how quickly it can rearrange itself after a disturbance. If a distant reconnection births a plasmoid, the signal of that birth races inward. If Io alters its volcanic mood, the magnetospheric heartbeat changes pitch over days and weeks as the torus swells or thins. At the deepest level, the field says that motion and electricity live in constant exchange. Heat rising from compressed depths stirs the metallic ocean. Rotation forces that stirring into alignment. Composition gradients steer it toward or away from certain radii. The product is a field that wraps the planet like a second atmosphere, one made of geometry rather than molecules. It holds a memory shorter than stone but older than storms, sensitive to slow rearrangements in the dynamo and to swift injections of plasma that ride the night side like weather. Night over the poles is never wholly dark. Curtains rise, fall, and ripple, their edges sharpened by electrons guided along lines like beads on wires. Far below, the belts and zones continue their own contests. Between them lies this labyrinth, a middle kingdom where invisible threads pull at both space and air. To trace them is to read the planet's handwriting, the calligraphy of a conductor in motion, the language of a world that speaks in arcs and ovals, and in the silent push of forces that leave light as their afterthought. A thin veil orbits in the dark, almost too faint to admit its existence. It glows only when the geometry is kind, forward scattered sunlight, turning dust into a quiet halo. The veil is not a single ribbon but a set of breath-like layers. Closest in, a main ring lies like a whisper along the equator. Beyond it, a gauzy sheet spreads into a gossamer drift. Inside, a tight torus leans against the planet's shadow. Tiny moons glide near the edges, unseen until they eclipse a star or reflect a pinprick. Their surfaces are chipped by micrometeoroids, each impact tossing grains into orbit. Gravity and the magnetosphere herd those grains into families. The result is fragile architecture, constantly replenished, constantly eroded, a dust ecology that survives because it is renewed faster than it fades. Within this translucence, patterns appear that are not explained by moon shepherding alone. Subtle ripples march around the ring, their crests spaced by distances that hint at a tuning fork held somewhere far below. The cause begins in the planet's own body. A globe of fluid can behave like an instrument. Push it and it vibrates in global modes, each a standing wave of density and pressure that wraps the interior with a particular rhythm. Some modes are surface F waves that shake the outer layers like the skin of a drum. Others are P modes that push sound waves inward and outward. Deeper still, G modes soar through stratified regions where buoyancy restores displaced parcels to their preferred level. Each mode rotates at a pattern speed defined by internal structure and by rotation, and each slightly reshapes the gravitational potential in space. Where the rotating potential of a mode meets an orbital radius that satisfies a resonance, the ring does not remain indifferent. Particles feel a periodic tug at the same point of their orbits, a nudge that adds coherently over many revolutions. The condition resembles the resonance for a moon, except that the perturbation comes from inside rather than from a shepherd. At such an inner Lindblad resonance, the tug launches a spiral density wave. Its crests carry the signature of the mode that excited it, the azimuthal wave number, the pattern speed, the amplitude. In a more ideal laboratory, the wave would be traced with calipers and equations to recover the properties of the interior. In this delicate system, that ideal is complicated by dust physics and by lightness itself. Yet even there, the principle holds. The ring can act as a seismograph laid in orbit. A different kind of wave lies like a subtle helical staircase twisted into the ring plane. It is a vertical corrugation, a tilt that slowly winds up under the pull of the planet's oblate gravity field. Such a structure can be born from a single event that tips the ring plane slightly, perhaps the impulse of an impact that pitched the dust sheet. As the planet's equator precesses, the tipped sheet winds into a tight spiral. Unwinding the spiral in mathematics takes one to the epoch of the disturbance, a timestamp encoded in geometry. The ring records not only steady music from within, but also sudden shouts from without. Both become patterns that persist long after the cause has cooled into memory. The dust is light enough to be bullied by fields, not only by gravity. Charged grains feel the magnetosphere and experience a Lorentz force that slides them inward or outward, depending on charge sign, grain size, and local field orientation. This non-gravitational shepherding alters how quickly waves damp and how cleanly they appear. It can steepen crests or blur them. It can make one side of a ringlet look sharper than the other. In the reading of waves, allowance must be made for this electric weather, or the interior's message will be interpreted through static. To hear the planet through its rings requires patience and geometry. Angles matter. When the sun lies nearly behind the planet, forward scattering floods the detector with ring light, revealing structures that otherwise remain below noise. When the sun sets low on the rings, shadows lengthen and vertical warps stand out. When the observer looks in thermal infrared, the ring cools and heats unevenly, and density variations show as temperature variations that move with local time. Every viewing configuration emphasizes a different stanza of the same poem. Over months and years, a complete reading emerges, and with it, the possibility of inverting the pattern into a spectrum of modes. The inversion is a dialogue between observation and model. For a given internal structure, theory predicts which modes are robust, how fast they travel, and how strongly they perturb the potential at the resonant radii. If waves at those radii are measured with wavelengths L and pattern speeds omega, constraints fall on the interior's sound speed and density gradient. Even a single well-measured wave narrows the range of acceptable models. Several waves turn a wide family into a short list. The discipline feels akin to helioseismology, where surface vibrations unpack the sun's stratification. Here, ring seismology offers a similar opening for a planet wrapped in cloud. The faintness of the ring demands cross-checks. One must separate a wave driven by a mode from one driven by a moonlet or by an external gust. Moon-driven waves repeat at pattern speeds fixed by orbital periods and are accompanied by the shepherd itself, if only as a slight clump of dust or a strobe in starlight as it passes a background star. Mode-driven waves lock to frequencies that are not harmonics of known orbits. They appear at radii where no moon mass has been found. Their pattern speeds track the planet's own rotation rather than any satellite's dance. As evidence accumulates, confidence grows that the ring is listening to its primary and not to a passerby. The language heard in the ring speaks of rotation within the planet. If the deep interior rotates at a slightly different rate than the atmosphere above, modes that feel a broad range of radii can carry the imprint of that differential. The pattern speeds then reveal a rotation profile, shallow or steep, a question otherwise attacked by gravity harmonics and magnetic drift. Resonant waves can thus test whether the equatorial jet slows significantly below the weather layer, or whether it threads deep before surrendering to magnetic restraint. The thickness of a stratified layer, if any, reveals itself in the spacing of G modes and in the strengths of their forced responses. The ring, tuned properly, becomes a ruler laid against the interior. Dust listens even to whispers. Low amplitude modes that would fail to affect a thicker, coarser ring can still leave a mark here, because the background density is small and the system is sensitive to small perturbations. That sensitivity is fragile. Meteoroid bombardment shakes the ring like rain on a membrane, adding noise to the seismogram. Radiation pressure warps orbits slightly. Plasma drag saps angular momentum. All these effects ride on top of the desired signal. Extracting modes becomes an art of filtering and of patient accumulation of long time series under many viewing angles. Moons near the ring edges act as punctuation. Metes and adrastea sweep out paths that gather and release grains, setting up wakes downstream that can interfere with waves. Their gravity fields are tiny compared to the planets, yet significant in the immediate neighborhood. The wakes carry their own wavelengths and can be subtracted if measured carefully, leaving cleaner access to global waves. In this way, the smallest companions assist the largest by first muddying and then, through characterization, clarifying the signal. Seismology teaches humility. A mode catalogue is a catalogue of what is possible for a given structure, not a promise that every note will be played loudly. Some modes are damped by viscosity in the interior or by radiative losses in thin, stable layers. Others are reinforced by coincidences in stratification that favor standing patterns. Over time, the spectrum of what the ring hears drifts with the planet as heat leaks away and gradients soften. Waves that once sang may fade, new ones may rise. The ring record is not a static page. It is a living notebook that updates slowly, page by page, line by line. The reward for decoding such a notebook is a portrait of a world drawn without landing, drilling, or diving. It is a map of sound, speed, and density that tells whether heavy elements are smeared into a gradient or piled into a kernel, whether a helium rain layer sets a boundary where G modes can resonate, whether the dynamo sits deeper or shallower than power alone would suggest. It is also a log of impacts and of magnetic weather, events that bend and tilt the ring and leave timed signatures that can be traced backward to their flashes. From a distance, the ring seems an afterthought. Up close, it is an instrument made of particles and sunlight, lying flat as if placed on a table for inspection. It feels tides from moons and pulses from the interior. It remembers sudden strikes and quiet oscillations. Threads of dust, stitched by gravity, become a listening device for quakes made of fluid, a lace seismograph circling a planet with no anchor. To read it is to hear a body the size of a small star murmur in its sleep, to feel the softened knocking of modes against a boundary that does not exist, to translate faint ripples into sentences about heat, rotation, and the long patience of hydrogen under weight. Heat rises even when sunlight retreats. The planet exhales more energy than it inhales, a slow radiance created by contraction, by separation of elements at depth, and by the long memory of formation buried in compressed layers. That extra warmth does not escape evenly. It threads upward along columns where gases lighten and ascend, then spreads beneath cloud decks that sometimes behave like blankets and sometimes like open windows. The choreography of heat is inseparable from the choreography of chemistry, because the agents that carry opacity also carry story. Water and ammonia are the main actors in this weathered theatre, trading phase, charge, and altitude, as if roles were costumes. Ammonia declares itself near the top. It condenses in cold updrafts, forming crystals that brighten high zones and paint the atmosphere in soft whites when the air is rich. Where air descends, those crystals sublime and vanish, revealing warmer layers that glow in infrared through thinned haze. But the distribution defies simple symmetry. Broad deserts of ammonia appear where downwelling has robbed entire belts of their soluble load. Elsewhere, plumes rise like chimneys and flood long lanes with vapor, then drift with the wind to create scalloped edges and trailing veils. The pattern proves that chemistry is moved by wind as much as wind is moved by chemistry. A column that reads dry aloft may conceal a reservoir below, waiting for the right instability to pull it upward in a sudden bloom. Water keeps its power at deeper pressures. When rising parcels cool enough to cross the line where vapor becomes liquid and then ice, latent heat is released in a rush. Towers develop that dwarf the largest storms of smaller worlds. Charge separation within them, seeds, lightning, and the flashes betray the altitude where ice and liquid collide. The bolts carve silhouettes through cloud, split-second X-rays of terrain made of vapor. Each strike is both release and trace, marking places where heat has forced a path through stratification that often resists. The storms are infrequent compared to the smaller planet with oceans, but when they erupt, they rework kilometer-thick layers and redistribute volatiles over basins as wide as continents. Not all precipitation is honest rain or hail. In zones where ammonia vapor is plentiful and water ice is abundant, ammonia dissolves the ice into a slush that grows heavy and falls. These pellets carry ammonia downward to warmer depths, where they melt and release it far from the place of origin. The effect is a siphon that drains the upper troposphere of ammonia along certain paths while enriching pockets below. At cloud top, instruments looking for simple vertical profiles find knots of scarcity and surplus where circulation has been busy. In belts, downwelling dries the air and accelerates the cleanse. In zones, recurring updrafts replenish supplies and sustain bright, cold caps. Phosphine appears as a messenger from hot layers. It should not exist in equilibrium in cold air, yet it is found in the upper troposphere, a tracer lifted by convective fingers from depths where temperatures allow it to be stable. Its presence outlines the highways of transport that rise through the weather layer. Variations in its abundance trace where upwelling has been vigorous and where air has been trapped beneath inversions. Sulfur compounds and hydrocarbons add their signatures, each marking a different pressure level and telling how quickly photochemistry can erase what convection writes. The sky becomes a palimpsest of reactions and transports, overwriting itself with each outbreak and clearing. Heat balance depends on opacity, and opacity is built from molecules that absorb and emit. Ammonia and water dominate at different depths. When ammonia snows out, windows open for thermal radiation to escape, cooling the region and inviting subsidence that dries it further. When water clouds thicken below, radiation is trapped and energy rises preferentially through convective overturning. The two create a feedback that helps set belt and zone personalities. Belts, with their clearer layers, leak heat efficiently and favor sinking motion. Zones, capped with reflective ammonia clouds and deeper water storms, trap heat and favor ascent. Yet the planet refuses perfect alternation. Lateral exchanges, waves, and transient storm systems throw exceptions that matter for months. At even higher altitudes, where gas thins and sunlight carves molecules into radicals, a cold cap forms that would collapse into deeper slumber were it not for energy arriving from above and below. From above, currents along magnetic field lines deposit particles that heat the thin air into a thermospheric glow. From below, gravity waves launched by storms in the troposphere steepen and die, their energy turned to heat. The soft temperature, maximum far from the surface, is an accounting line where these incomes balance radiative losses. The warmth does not drive the weather below, but it closes the book on the upper boundary and feeds back into the rates at which molecules recombine and settle. Internally, the glow that exceeds sunlight's gift stems largely from slow contraction. As the planet adjusts toward a tighter configuration under its own gravity, potential energy becomes heat. Added to this is the warmth of helium separating out of hydrogen at depth and raining down. The downward drift of droplets releases gravitational energy that warms deep layers and slightly cools the regions above, shifting gradients in a way that changes how buoyancy produces motion. With time, the combined processes diminish, but the clock is slow, measured in billions of years. That slowness is why the air still rises with a purpose even in the absence of strong solar forcing. Not all gradients encourage overturning. Where heavy elements enrich deeper layers, a stabilizing hand rests on convection. Heat must flow through many thin overturning steps, instead of through vigorous columns that connect center to cloud. This layered transport spreads the internal energy release over a greater range of altitudes and gives moisture and ammonia more chances to become trapped or liberated by local conditions. The approach of the temperature profile to an adiabatic curve is slowed, and with it, the speed at which volatile reservoirs refill or empty. The consequence is a weather pattern that can retain memory, repeating certain outbreak latitudes and maintaining deserts of ammonia for long stretches. Radiative timescales lengthen with depth. because opacity and density both rise. A parcel displaced slightly loses or gains heat slowly. Instabilities that might run away in a thin atmosphere evolve more deliberately here, waiting for latent heat or for waves to provide a nudge. When the nudge arrives, the response can be spectacular. A plume born at 10 bars can run to the cloud tops with the force of released potential energy, overshooting, spreading anvils that shade neighboring columns, and setting off a cascade of gravity waves that carry momentum outward. The anvil cools, snows, and collapses, and the cycle seeks a new equilibrium that rarely lasts. Ammonia does not only condense and rain, it adheres to dust and ice surfaces, it forms salts with sulfide, and it coats particles that act as nuclei for further condensation. These microphysical choices control how readily clouds form and how large their particles grow. Large particles fall, clearing the sky. Small ones linger, turning sunlight aside and hiding deeper warmth. The distribution of sizes is a memory of the updraft that built the cloud. Stronger plumes lift smaller grains higher and keep them aloft longer. Weak plumes build heavier, quicker rainouts. The appearance of the planet's bands, soft or sharp, white or tawny, is therefore a tale of particle physics played out at a scale that wraps a world. Water vapor at depth carries the greatest latent energy, but its mixing ratio is limited by formation history and by how much dissolving has shuttled oxygen into the interior. Where water is richer, storms become deeper and more electrically active. Where it is scarce, convection struggles to climb, and belts display their dark windows more frankly. The mapping of these oases and deserts in water is not trivial, because the clouds they build also hide the layers from certain senses. Microwave paths thread the weave, infrared glimpses through gaps, and gravity reveals the aftermath of mass rearrangements. Put together, these senses describe water as a sculptor of structure, more than an ornament of cloud. A subtle player lies in the spin states of molecular hydrogen. Two varieties with parallel or antiparallel nuclear spins interconvert on timescales tied to temperature and catalysis on aerosols. The ratio can fall out of equilibrium in regions of quick uplift or descent. Because the varieties have slightly different heat capacities, the ratio feeds back on temperature structure during rapid vertical motions. This minor detail becomes a minor brake or booster for plumes depending on history, a small lever that matters only because everything here is large and long enough for small levers to accumulate effect. The total picture is not a map of fixed bands, but a living budget. Heat arrives from the deep interior like wages earned long ago. Sunlight adds a seasonal stipend, thin but effective near the top. Ammonia and water decide how those incomes are spent, on reflection, on radiation to space, on cloud building, on lightning. Mushball rain and downwelling advection move funds between accounts. Phosphine and other disequilibrium species broadcast how rapidly transfers are occurring. Gravity waves and magnetic coupling add service charges and bonuses. The ledger balances through time with oscillations rather than with straight lines, and the eye sees the balance sheet as color, texture, and flash. Patience reveals patterns within the seeming caprice. Certain longitudes invite plumes more often, where jets and waves focus convergence. Certain latitudes shelter deserts, where sinking motion and transparent windows help the planet cool. The asymmetries drift and then return as the deep heat trickles upward through a maze of composition, condensation, and radiative escape. The result is an atmosphere that never stops moving energy and never settles into monotony, because the carriers of that energy are also the pigments and the seeds. In the rise and fall of ammonia and water, the planet retells its story of warmth inherited, redistributed, and released. A story written each day in clouds and each night in lightning, measured not in seasons but in the long breath of a giant. A giant begins where ice turns from memory into matter. In the young disk, sunlight falls through dust and gas and meets a boundary where water can rest as frost upon grains. Beyond that frost line, pebbles form by the millions, each a union of silicate dust and volatile ice, sticky in the chill and easy to grow. Turbulence stirs them, drag slows them. They drift inward like a slow rain, a river of solids sliding through gas. Where an eddy or pressure bump gathers the stream, mass collects and settles into a seed. Gravity follows. What was haze becomes body. Pebble accretion does not look dramatic from a distance. It is the quiet theft of countless small things. A protoplanet barely larger than a mountain reaches out with its gravity and turns passing pebbles into spirals that end on its surface. Gas acts as accomplice. Slowing the pebbles so capture becomes efficient. If the flow continues, the seed grows quickly, measured in hundreds of thousands of years rather than tens of millions. Each swallowed pebble carries water, organics, nitrogen-bearing ices, and noble gases trapped at low temperature inside clathrate cages. These deliveries build the reservoir of heavy elements that later chemistry will reveal. The seed does not stay small for long. When its mass crosses a threshold, its own gravity holds a cushion of gas. From then on, the story accelerates. Runaway capture begins when cooling allows the cushion to contract. A thinner envelope draws in more gas from the disk. Pressure at the base rises, releasing more heat, which is radiated away as the envelope loses entropy. The contraction speeds the inflow. The process feeds upon itself until the envelope's mass rivals that of the core. A giant is born in the time it takes a gas-rich disk to thin. The clock is brief by cosmic standards, perhaps a few million years, set by how quickly young stars shear and irradiate their disks into dispersal. A planet that lingers too long as a partial giant will find the pantry bare. This one did not linger. It arrived in time. Formation writes itself into composition. Solids built beyond the frost line carry more heavy elements than the solar gas around them. Swallow enough of those solids and the envelope becomes enriched. The ratios of carbon, nitrogen, sulfur, and noble gases rise above the star's pattern, not uniformly but according to the temperatures at which their carriers condensed. If amoral dynamics scatter cold fragments inward from farther reaches, the enrichment tilts towards species that require deeper chill to be trapped. The giant's air becomes a ledger of what it ate and when it ate it. Later, convection and mixing blur the handwriting but do not erase it. Disequilibrium gases lifted from depth keep the script legible enough for those who can read between lines. Growth disturbs the neighborhood. A body large enough to pull gas inward also carves a partial gap in the disk. Angular momentum trades hands across the gap like a currency. The planet migrates as it pushes against gas inside and outside its orbit. Sometimes the movement is outward, when torque from the inner disk wins. Sometimes inward, when the outer disk pulls harder. Small changes in opacity, temperature, and surface density can reverse the sign. A world of this size feels each variation. It rides the currents of a medium that is itself evolving. Migration rearranges resonances, shepherds, planetesimals, stirs debris, and rewrites the inventory of solids available to other embryos. A single giant can sculpt a system even before its moons congeal. Violence attends success. Embryos do not always avoid one another in a crowded nursery. A late impactor, as massive as a small planet, can arrive on a shallow trajectory, its path curved by gravity and its fate sealed by the absence of ground. The intruder dissolves into the envelope. Rock and ice strip into atoms, then ions, then a cloud of heavy elements that sink and mix. Shock waves race outward, heating the gas and stirring composition. The energy of one such event can rival the internal heat budget for years and leave long-lasting consequences. As heavy material diffuses and settles, a gradient forms instead of a boundary. The heart ceases to be a single object and becomes a region where heavy elements are most common. The dilute core is the fingerprint of a collision smoothed by time. Growth also spins. Gas captured from a rotating disk carries angular momentum, and the planet accepts it. Rotation shortens the day and flattens the poles. The shape becomes a clue to speed. The fast turn then shapes the atmosphere that will form from this gas, setting the stage for jets and gyres before any cloud is born. Spin fixes the tilt of magnetic cylinders at depth. What begins as a receipt for angular momentum in the disk becomes the metronome for all future weather and for the dynamo that writes auroras into polar night. Moons emerge from the leftover material swirling just above the cloud tops, a circumplanetary disk born from gas flows that deliver mass across the main gap. In that disk, dust coagulates into satellitesimals that snowball into worlds. Their compositions differ according to where they accrete in the miniature disk. Inner regions warmer and drier, outer regions colder and more generous with ice. Some irregular companions arrive later, captured during 3-body encounters or by passage through gas that damps their wild orbits into residence. They become archivists of the early environment, carrying surfaces that remember bombardment and dust that tells of slow, continuous erosion. The faint ring born from impact dust in the inner reaches is a side effect of this ecosystem, not a separate creation. The giant's presence modifies the chemistry of the wider system. It locks smaller bodies into resonances that pump eccentricities and trigger collisions. It drops fragments inward where they seed atmospheres on rocky worlds with water and complex organics. It also denies some embryos their future, ejecting them into deep space or merging them into larger bodies. With each gravity assist and collision, the giant becomes a central broker of matter and motion. The architecture of the system owes as much to this brokerage as to the original distribution of solids and gas. Time does the slower work. After the gas disk fades, the planet contracts by fractions, turning potential energy into heat that seeps outward across ages. At depth, helium loses its willingness to remain mixed with hydrogen and condenses into droplets that fall. The rain warms layers below and changes the composition above, a gentle redistribution of mass that preserves the memory of early conditions while continuing to reshape the interior. The diluted core, the conductor that hosts the dynamo, and the weather layer above all adjust to the new balance. The process never rests. It proceeds across epochs, its pace set by opacity, composition, and pressure. A more speculative thread imagines that radial drift of pebbles, concentrated heavy elements towards certain bands in the disk, creating sweet spots where growth could leap ahead. If such a pressure trap formed near the frost line, solids would have piled into a belt from which accretion could drink with both hands. The forming giant would then be a consequence of a local quirk amplified by feedback. As it grew, it would modify the trap itself, perhaps shepherding pebbles outward and cutting off its own supply. The resulting envelope would bear the imprint of a feast that ended when the diner removed the table. The gradients now sensed in ammonia and water could be viewed as distant echoes of those first biases. At the scale of the star, magnetic fields threaded through the newborn system guide winds that remove gas. Those same fields enforce patterns of accretion within the disk, creating rings and gaps even before any planet can claim responsibility. A forming giant tunes itself to that magnetic architecture as surely as it responds to gravity, drawing gas along channels where viscosity and field allow. If the stellar wind ramps up and the disk disperses more quickly, the giant freezes with less gas and a relatively larger share of heavy elements. If the dispersal is slower, the envelope swells. The final mass and composition are not single-valued, they are integrals of a history. The theft in this story is not a moral failing, it is growth by capture. The planet steals pebbles from drift, steals gas from a disk that will soon vanish, steals angular momentum from spirals in the nebula, steals heat from its own contraction, and perhaps steals a nascent world that strayed too close. Each theft becomes a gift of structure. Enrichment gives chemistry to weather, gas gives skin to gravity, spin gives rhythm to motion, impact gives gradient to the heart. Out of these bargains, a world large enough to influence everything around it takes shape. What stands at the end of assembly is not settled stone but a machine still adjusting. The interior carries gradients left by accretion and impact. The envelope records the inventory of cold cargo delivered by pebbles and planetesimals. The rotation set during gas capture governs how flows align and how the dynamo breathes. The moons recite the history of the circumplanetary disk. The faint ring remembers impacts that grind small worlds into dust. None of it is static. The giant continues to edit itself, each slow adjustment a footnote to a fast youth written in heat, drift, collision, and the patience of a disk that briefly provided the ingredients for a planet to become more than a cloud. New instruments wait at the threshold like keys set on a table. Each promises a different lock, a different door into pressure, motion, and hidden light. Some keys belong to machines that will fall. An entry probe can ride a heat shield into the cloud-top dusk, jettison armor, and open its inlets to taste the air with deliberate breath. Mass spectrometers will weigh molecules and noble gases, not as hints but as counts. Tunable lasers will measure isotopes, telling apart waters born from different snowfields in the young disk. A pressure vessel will cradle sensors as they descend through the ammonia deck into the deep water realm where lightning is born, sampling winds by Doppler and humidity by absorption, watching the temperature lapse rate tilt with condensation and relax after rain. The signal will fade at last into static, but the profile will remain as a vertical poem no model can invent. Balloons can linger where a probe cannot. A hydrogen-filled envelope, covered in reflective skin and fed by sunlight or nuclear warmth, can float within the weather layer for months. It will surf shear, drift in and out of plumes, and send back a diary of turbulence. Microphones will hear thunder as pressure waves and count the distance between strokes. Nephelometers will size particles, telling whether mushball rain is falling nearby or whether thin mist has taken hold. A flotilla of such drifters could map the world of 10 bars the way ocean buoys map currents, revealing the difference between uniform flow and a tangle of corridors. Orbiters can become listeners as well as watchers. A pair of spacecraft can pass on either side of the planet and trade laser pulses, timing each tick to picoseconds. Any tug from deep winds or from a diluted heart will shift their pace. The method turns gravity science from single track to stereo, strengthening the inversion that translates motion into mass. A third craft, skimming close, can throw radio waves through the limb and watch them bend, converting refraction into sharp vertical profiles of temperature and refractivity at many latitudes. The puzzle of winds with depth, once solved by harmonics alone, would then be solved by the combination of harmonics and slices. Magnetism invites sharper ears. Vector magnetometers cooled to hear fainter whispers can map small gradients in field that drift with the season of the dynamo. A low periapsis polar orbiter can arc repeatedly over the same patch of latitude and watch the field meander like a slow river, constraining how fast flows creep within the metallic ocean. Magnetoseismology can attempt to hear internal waves that tug field lines at frequencies set by conductivity and stratification, translating those quivers into the thickness of the conducting shell and the stiffness of composition gradients that lie below. Rings will continue to act as quiet seismographs, but their sensitivity can be improved by staging eclipses with purpose. When the planet passes across a bright star, imagers with rapid cadence can track the flicker of starlight through the ring and read the fine comb of waves with unprecedented precision. Multi-wavelength occultations will separate particle size effects from density waves, leaving cleaner access to the frequencies that belong to modes. Correlating these detections with independent gravity and magnetic measurements will triangulate the internal rotation profile that otherwise remains an inference. At the poles, auroras are more than spectacle. High-resolution ultraviolet and infrared spectrographs on a dedicated polar orbiter can map energy inputs from the magnetosphere into the upper atmosphere, frame by frame, tracing how heat spreads equatorward in thermospheric tides and how that warmth alters the winds far below. A suite of particle detectors can count the contributions of electrons and heavy ions, tying bursts of precipitation to injections from the magnetodisk and to the restless torus built by a volcanic moon. The timeline of these inputs, matched against changes in jet strengths, may reveal a faint chord that links space weather to atmospheric rhythm. Laboratories on Earth have their own doors to open. Diamond anvil cells will push hydrogen and helium into pressures that force electrons to wander and will hold them long enough to measure conductivity, reflectivity, and compressibility across ranges that modelers currently guess. Laser-driven shocks will add dynamic paths through the phase diagram, building equations of state that respect both static and transient extremes. Water, ammonia, and methane will be forced into superionic phases and measured for thermal and electrical properties, closing the gap between theory and the deep weather that depends on those numbers. Computers will host worlds of their own, grown from equations rather than gas, but faithful to the same constraints. Global circulation models will learn to carry moist convection from microphysics to planetary scale, nesting little storms within great jets and letting them trade momentum rather than prescribing it. Magneto-hydrodynamic codes will be coupled to these models so that jets feel the resistance of field and field feels the heave of flow. Data assimilation will turn observations into nudges that keep simulations honest, pulling analysis toward reality with every new pass of a spacecraft, every new image from a mountaintop, every new spectrum from a telescope in orbit. The largest mirrors planned on Earth will become windows into the moving top, their adaptive optics ironing the air enough to resolve filigree at the limit of diffraction. A night of good seeing will be enough to watch a plume bloom from a belt and chart its drift under shear, to count the small eddies that peel from the rim of a vortex, to measure the color changes where photochemistry works fastest. Filters tuned to narrow bands in the near and mid-infrared will separate heights, revealing high ammonia haze above and warmer layers below, turning simple portraits into layered maps. Polarimetry will add the angle of light to the ledger, constraining particle shapes and sizes in clouds that otherwise hide their design. A small armada of flyby craft can be timed to share the load of sampling. One can carry a microwave eye tuned deeper than those before. Another can bear a sub-millimeter limb sounder to sense temperature and trace gases in the tenuous upper air. A third can be nothing more than a compact magnetometer and plasma suite designed to traverse the equator where the magnetodisk breathes. Their data can be stitched into a single product if they fly in coordinated arcs, building a map of a living planet from pieces that no single craft could gather alone. More speculative techniques lie just beyond reach. Atom interferometers, sensitive to tiny accelerations, could ride in cold, quiet spacecraft and measure gravity gradients with a fidelity that turns millimeters per second into narrative. Acoustic sounders dropped in tandem could trade pings across layers and work as a crude sonar in gas, timing the path and inferring density structure between them. A gentle impactor could strike the ring at controlled speed, creating a test ripple whose damping rate would calibrate the viscosity and collision properties of ring particles, sharpening the translation from ripple shape to interior mode. Citizen astronomers will remain quietly essential. Fast cameras and clever software on backyard telescopes can catch the first signs of outbreaks and mark their drifts with timestamps that cannot be duplicated by any single national program. Their vigilance extends the reach of professional facilities, supplying the context needed to aim the largest mirrors and the deepest radio ears at the right longitude and latitude when a rare event begins. Global networks of amateurs form a mesh that no cloud deck or day job can defeat, a patient instrument spread around the planet. Exoplanet astronomy will supply calibration by contrast. Giant worlds around other stars, some hot and some temperate, will show their own jets through Doppler shifts of spectral lines and their own magnetic signatures through radio bursts. Comparative study will then frame the home giant more sharply. If a hot world shows a single broad jet under intense stellar heat, and a cool world shows many under dimmer forcing, the differences will talk about the roles of rotation and heat source in setting jet count and reach. If a distant magnetosphere flickers with the pace of its rotation, it will show how metallic layers can be deep or shallow in other circumstances. Every distant measurement is a mirror that clarifies the nearby. Detectors will become quieter and clocks more precise. That simple improvement turns integration time into revelation. Weak lightning on the night side, barely sensed as a tick in a noisy band, becomes a map of storm birth when the noise floor falls. Minute wiggles in a ring edge, once shrugged off, acquire frequency and phase, and thus become modes with names and radii, with errors measured in confidence rather than in hope. Precision is courage for inference. With it, models can risk detail and be punished when wrong. A final key is philosophical, but it has engineering teeth. It is the discipline to accept gradients where walls seem easier, to code layered convection where simple overturning is tempting, to admit that magnetic drag does not turn jets off, but bends them with depth in subtle curves. It is the willingness to build instruments that measure slowly and well, to wait through many orbits for secular drifts in field and gravity. to believe that a ring can be a seismometer and a balloon can be a laboratory. This patience draws maps that do not need continents, and it digs cores that do not need drills. The doors will not all open at once. Each key turns a small lock, and each open door reveals a hallway of others. The reward is the chance to watch a giant speak in its natural language, to hear heat and composition converse, to see magnetism answer to motion in a sea that knows no shore. With such tools, a cloud planet becomes a measured world, and a veil becomes a window polished by time, by curiosity, and by the steady confidence that every whisper from that depth can be turned into understanding if the ear is patient enough. He looks like a storm, but he behaves like a mirror. In his turning light, a species of shoreline walkers sees its own beginnings recast as weather. Hydrogen, the first breath of the cosmos, gathers in layered seas and learns new accents under pressure. Helium drifts like soft rain in darkness. Heat remembers a long contraction and keeps its promise to rise. What appears as distance becomes intimacy, because the ingredients that move within that globe are cousins to the breath that moves within warm lungs and to the water that climbs against gravity inside a leaf. Scale does not cancel kinship, it reveals it. An eye trained on clouds learns patience, then carries that patience home. The discipline required to time a radio pulse against the tug of gravity is the same discipline required to listen to a friend without interruption. The restraint needed to avoid simple answers when odd harmonics point to deep winds is the restraint needed to refuse quick anger when uncertainty rakes the mind. A planet without a surface teaches gentleness to creatures who long for ground. Meaning must be inferred rather than touched. Truth must be approached, not seized. Such practice changes the student. There is courage in admitting gradients where borders would be easier. In a world that prefers slogans, it feels radical to say that the heart can be a region, not a lump, and that identity can be a slope, not a cliff. The lesson travels. Minds are not homelands with walls and gates. They are profiles in time, richer here, thinner there, warmed by memory, cooled by doubt, stirred by encounters that dissolve certainties into new alloys. He keeps that wisdom under clouds and offers it without speech to anyone willing to watch lightning by night and not mistake brightness for the whole of light. Rotation sets a rhythm that becomes parable. A rapid spin turns chaos into parallel streams and vortices into geometry. There is no mountain to guide the flow, only conservation of what matters. A life can be governed the same way. Keep what must be kept. Admit what must be admitted. Let the unavoidable turn shape the path, and beauty will rise even when intention fails. In such a frame, setbacks become eddies that feed the main current. Accidents become vortices that last long enough to teach, then give themselves back to the river from which they were built. The magnetic ghost that surrounds the planet is a reminder that unseen structures sit beneath visible behavior. A field born in a conducting sea keeps auroras burning and bends the roots of particles that never see a cloud. Human choices ride similar scaffolds. Values set in early pressure guide later motion. They are not visible in the daily weather of expression, but they glow in crisis, and they hold shape when the solar wind of circumstance presses hard. If those values are tangled and patchy, the auroras will ripple in odd places. If they are strong and continuous, curtains will stand with solemn grace. In either case, the light tells truth about the hidden sea. Lightning in high towers writes momentary letters into vapor. The strike is loud, but the river of heat that powered it is quiet. That proportion feels familiar. Headlines crackle like storms. The slow work of care rarely earns a flare, yet the planet proves daily that slow work drives everything that lasts. Contraction that no one can see feeds the jets. Separation that no camera can celebrate warms the depths. The spectacle is payment, not purpose. A species hungry for spectacle can learn to be hungry for the sources that permit it. The ring that hears interior quakes turns a veil into an ear. That conversion is an instruction. Take what seems decorative and listen with it. Take what seems peripheral and let it teach the middle. The method carries across disciplines and across hours. A child's quiet question at the edge of a conversation can reveal the core of the topic. A faint shift in a tone of voice can serve as a seismogram for a friend's day. Attention is an instrument whose sensitivity increases with use. He rewards that attention with ripples that turn into numbers, that turn into models, that turn into recognition. Storms can live for a century because nothing interrupts their supply and nothing drags their skirts across rock. Longevity here is not stubbornness, it is proper placement. An eye that learned where food arrives can outlive empires through balance alone. The metaphor is gentle and is offered without moralizing. Find the shear that feeds you, avoid the walls that break you. Accept that you are part of a larger circulation. Give away vorticity at the edges and receive it back in clean filaments when the river permits. A life lived like that will throw off streamers of kindness that others can pick up and braid into their own weather. Heavy elements diluted through the heart tell a story about tenderness with strength. It is possible to be massive and still allow mixing, to be central and still allow exchange. Power need not harden into singularity. It can spread as invitation. In this world, the invitation makes the dynamo possible and spreads heat in graceful steps. In a mind, the invitation keeps learning alive. When the center remains porous, the field that surrounds it remains humane. A pole crowned with cyclones becomes a mandala of motion. Each vortex holds station because each respects the push and pull of its neighbors. That is not peace in the sense of stillness. It is peace in the sense of negotiated persistence. It proves that arrangement can provide endurance without requiring sameness. The configuration even allows drift, slow and dignified, an acknowledgement that time alters everything and that stability can be a traveling feature rather than a fixed address. The glow above the atmosphere seems showy at first, then reads like a ledger of inputs and losses. Energy arrives from inside and from space. It is transformed into color, heat, and wind. It escapes tonight. Nothing is wasted. The same is true of days. Attention becomes understanding. Understanding becomes action. Action becomes a trace in someone else's sky. The giant is not a moralist. It is a mathematician that happens to be beautiful. It shows balance sheets filled out in light. Solitude serves the planet well. No mountain rises to complain. No ocean carves a coast. Yet companionship defines the system. Moons exchange dust, share electric paths, and leave freckles on the face during transits that pass without sound. The quiet companionship of those small bodies is a model for loyalty that does not interrupt. Presence can be influence. Proximity can be love without rhetoric. A tiny shadow on a bright band is enough to say we are here together. Silence is a teacher in front of this world. There are moments when instruments sleep and the planet continues exactly as it has for ages. The clouds throw shadows on clouds. Lightning softens the wings of bats of darkness that fold and unfold among the belts. In that silence, the mind moves toward long questions. What does it mean to begin in heat and spend ages turning potential into radiance? What does it mean to inherit a glow and steward it without haste? These questions do not require answers to be valuable. They require only breathing in and breathing out under a sky that is both alien and familiar. At the smallest scale, the planet instructs in humility. When the spin states of hydrogen matter to the temperature profile of a parcel, when the adhesion of ammonia to tiny grains changes the fate of a cloud, when milliseconds in a radio phase translate into a new coefficient of gravity, the magnitude of the whole does not erase the importance of the small. Lives play out at that scale too. Tiny repairs to language change the weather of a conversation. Brief pauses avert storms. A shared look reflectively aligned with a quiet value can deflect an entire current. The mirror closes with a simple reflection. The world wrapped in bands is not a riddle posed by an enemy. It is a gift from heat and time. It waits without impatience while minds learn how to hear. It permits approach by light, by field, by wave, by dust. It yields a little with each method and holds much back, not out of malice but out of size. The remainder is not failure. It is the reserve that keeps wonder from running dry. A species that loves answers needs some rivers whose sources always remain around the next bend. In that sense, the giant is not only a place, it is a practice. Look, listen, infer, doubt, test, accept gradients. Refuse easy borders. Expect beauty where mathematics governs, and be ready for mathematics where beauty appears. Carry that practice back to shores and to rooms where talk is quick and stakes are real. The planet will continue to turn. Lightning will flash with no audience. Auroras will lace the poles with no applause. But in one corner of the same cosmos, a mind will be quieter, and a hand will be gentler, because a globe of hydrogen taught patience with its storms. Night keeps its glass dome over the disk, and the room grows small and kind. The giant drifts in the window like a lantern set far out on black water. Its bands are a script too fine to read with hurry. Its light is a story told in breaths. A soft radio tick holds time to the turning. The table cools. The pencil stops. The mind steps back. Wind becomes a memory of sound rather than a roar, a hush like fabric drawn over a chair. Lightning fades to thought, not to shadow. The aurora loosens its green ribbon and lets it fall into the dark where colour waits for another hour. Rings pass in thin silence, a lace laid down by hands that never tire. Moons slide, steady as prayer, steady as sleep. There is no final page. There is an open drift. Heat will keep moving outward with grace. Helium will keep sliding into rain 1,000 miles down. The magnetic ghost will keep lifting curtains at the poles for anyone with patience to watch. None of it asks for witness. All of it rewards kindness in the gaze. A world does not grow smaller when it is understood. It grows more itself. Close the notebook. Leave the telescope to guard the window with its soft eye. Carry the quiet back through the hallway where clocks argue in seconds and doors make their little weathers. Remember that a planet with no ground can teach how to stand. Remember that a storm can be a teacher and that a ring can be an ear. Sleep accepts the lesson without words. End of script. Sweet dreams. Bản GPT mới. Tiếp tục trò chuyện để sử dụng phiên bản cũ hoặc khởi động một đoạn chat mới cho phiên bản mới nhất.